Happy Monday. Monday. It's Monday. Let's put my lights on. Ooh, there we go. That's a nice tint. Nice purple tint. So yeah, today we are training ImageNet. It's a big day for the Tiny Corp. We have today, tomorrow, and Wednesday to do it. And then I'm going to Austin for a wedding. So then I gotta leave. And then if we don't do it by then, we're failures. But if we do it by then, we are successes. And we can celebrate our success. I don't know how will we celebrate our success. You guys can figure it out. Hello, good morning. Okay, so you missed it, but I downloaded ImageNet. We couldn't sit here and wait. Like, these files are huge. 160, 38 gig. And then I downloaded this prepare script. I Googled ImageNet prepare script, and I found this one, and I did it. And we can like look in here and like train. Let's see what we got. There's a bunch of images. Hopefully they're all safe for work. Look, here's a shark. Okay, so these are the ImageNet images. That looks bigger than 224 by 224. But we're not going to ask too many questions. I think these are all too big. I think if we actually like reduce ImageNet to like a reasonable size, it'll work better. And then there's some like list somewhere of what these categories actually correspond to. Is there? Val? Maybe not sure. Where does it tell me what these categories actually are? Oh, that's a bustard. How's the job market? Well, we're on the other end of the job market from you. We are trying to hire people. How is hiring people? Oh crap, I left the Wi-Fi on. Be back. All right, cool. Where are the ImageNet categories, and how come this prepare script didn't include them? That's very weak. And why are crane and mallet labels duplicated? Oh, we have 2 cranes and 2 mallets. The labels here do not correspond. Does this one have double crane as well? Double mallet. Is that really true? That's a mallet. Is this also a mallet? Bro, they're both mallets. Also, what the hell's a mallet? You mean a one-piece bathing suit? Browse synsets? What's this? Turn this off. It's buzzing. Are there multiple mallets? This one doesn't have any mallets. Okay, it has 2 mallets, but it also has tank suit. I see. Ah, and this one just doesn't have the double. Okay. Main completion object localization. All right, whatever. I think I might actually already have this in tinygrad. Models, outputs, find star.txt. Yeah, this. Or is in cache class IDs? Oh, there we go. 911 is a category? Transfiguration? What is this Harry Potter crap? Wait, is this actually part of... Is this upstream tinygrad? Hype train, good morning everybody, good morning. No, it's all just get ignored. Okay, well, none of that's real. Okay, it looks like we're just gonna use this one. This one looks good. No, it not uses the original index ID. Here's one in JSON. We love JSON. Are there 2 Malliots? Bro, we're back in double Malliot land. Is this the same way the... We should check. All right, never mind. I'm getting. Okay. What? All right. You guys, we stay on topic here. We also have a tinygrad Discord now. There's a tinygrad Discord, but the rules for being on topic are insanely strict. If you post, it's not the George Hotz Discord. If you post any garbage, when are you gonna stream next? Get fucking banned. All right, I too don't live in a privileged area. You know what you sound like? You sound like one of them rap battle people. My hood that I grew up in is 7 times worse than the hood you grew up in. The things that I have seen are much, much scarier than the things you have seen. Your life is nothing compared to mine. If we were to throw down right now with fists, I would emerge the victor, right? You know what I'm saying? All right, good. We have a lot of work to get done, and we can't go off topic today, all right? Where did I put my face? Oh, it's over there, okay. So you can kind of not see. Here, ImageNet class index to labels, okay. How many Malliots are here? Oh, this one has Malliot tank suit, I see. I don't know, this one seems pretty good. Is 0 a tench? Okay, yeah, it's a tench. Tinka tinka. Okay. Tinka tinka. So we're gonna create a new folder in examples, and we're gonna call it ImageNet, and we're gonna do it. We're gonna make it happen. All right, ready? We're making it happen. So let me, let me explain what I wrote that made me optimistic for being able to actually do this. So we have this thing called benchmark train efficient net. I've upgraded it a bit. Oh, let's use GPU. So I've upgraded it a bit. It uses the cache. Oh, we have to enable the cache. CLCACHE equals 1. And you see that it gets much faster after the first 3 run-throughs, and then just starts flying through them. Choo, 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 choo. Right? But we have even something better, which is the kopt. So I can set kopt equal to 1. And look at that, it's 3 times faster. So this is doing a forward pass on a size 2 efficient net with batch size 8. And you see this is how many gigaflops we're getting. Now you can't actually see that because that's where my face is. So we're going to move my face up to here. All right, so you can see that's how many gigaflops we get. That's a good number of gigaflops. It's not actually training. We'll have to enable training, and that's a little bigger. We can also interleave, copy, and run. You see that not much of the time is spent in realize. Most of the time is spent waiting for CL, which means we have the CPU free, which is great. Now, there's only one little problem. I believe if I do test AST here, there are actually broken ASTs. So I'm just going to file an issue quickly. Let's see if we can find the issue. So kopt sometimes generates wrong code. Okay, it looks pretty good actually so far. Maybe I fixed the bugs. I probably not. We'll get to it. So this is testing each AST and confirming that there are no bugs. ASTs are the things that tinygrad compiles to. Maybe it was only a problem when I enabled training. Okay, it works. Let's enable training. Or maybe the problem was at a different batch size. Backward equals 1. We also, I'm not sure what net we're going to use yet. I like efficient nets because they're what we use at comma, but I am a bit old school. Maybe the problem was only at larger batch sizes because these seem okay. So I'm actually doing one intervention. If you guys were here for the last stream, I cleaned up, hang on, that's not what we want. Let's go to your code there. Oh, here we go. Okay, we got one wrong. Rarely, but it happens. Repro with. Okay, so now we have an issue on tinygrad. I'm going to assign the label to it, test failing. So if you are trying to contribute to tinygrad, these 3 test failings are very nice because they're very easy to know when you've fixed it. Yeah. So you can see that this is generating something totally different from this, and I wonder why. I wonder what intervention is actually breaking this, and I'm sure we can learn more about it. Yeah, okay, all that valid stuff looks a bit sketchy. Losing track of what? You get better flops with efficient net than ResNet. Honestly, I don't know. I haven't benchmarked ResNet yet. But so this is my benchmark trainer for efficient net, and you see that sometimes it has bugs. So you can enable it with test AST equals 1, which compares the output of the AST to the, actually we should confirm that it passes if I set kopt equal to 0, because there could potentially just be another problem. Kopt generates a little cache in your temp directory, which says what interventions to do for the kernel. If you saw, we actually wrote search last stream, so I upstreamed it. I cleaned it up nicely. I moved it to here. The only intervention that's allowed right now is upcast, but these are different interventions, and I changed search to be more of a breadth first search. So I do like all the things at one layer and then all the things at another layer. And this is only allowing one intervention because multiple interventions generate wrong code too. But debugging that doesn't sound like it'll make a fun stream. So we're not going to do it. Let's figure out what net we're going to use. So what are the state of the art now for training ImageNet? Okay, yeah, it works with kopt equals 1. So there is a problem in the optimizer. The optimizer can sometimes generate wrong code. And you guys should fix this. So this is the tinygrad Discord. A bunch of topics. This is kind of where we're going to coordinate. I think tinygrad's about to be like this stuff here is very exciting. The fact that I can get a 3x speed up with this optimizer, I'm pretty sure this is faster than PyTorch MPS. Oh, I also wrote some hacks in benchmark train efficient net here. You'll see that like this is the caching stuff I wrote. This should be replaced with @tinygrad.jit. So if someone wants to try that, that'd be cool. But that one might be hard. This one, we have a half-finished pull request for this one. I had 2 good first issues on there, and this one is failing the tests, and the README needs to be updated. This is not what I meant by updating this test. The problem with this update is it's still comparing. This doesn't really test like anything. It just tests that this 0 view matches the generated one, which is testing the functionality of pad, but not testing the functionality of 0 view. So if someone wants to do this issue is very much on the table as well. No, I'm not using nicks. No, fuck that. What is possibly hard to match? What dependencies? tinygrad has like 6 dependencies, and they're all like very normal stuff. I'm absolutely not merging in huge ass nicks. Though I've come around on Rust, okay? I hate Rust less. I've heard that I need to try Rust, and I have a 2016 opinion, 2017 opinion about Rust, and the language has come a long way. You don't need llvmlite. llvmlite is optional. You don't need llvmlite to do any of the stuff I'm doing here. If for some reason you have trouble installing that. I hate llvmlite as well. Really, llvmlite should be replaced by, like, there should just be some, like, Python and C type stuff that can replace that all pretty easily. I wouldn't mind replacing llvmlite. And actually just having it output the lvmir directly. Yeah, and then just, like, write a little thing to compile it. Actually, if someone wants to do that, I wouldn't mind removing llvmlite. I think it's overly complicated. I wouldn't mind removing opencl as well. So you'll see I factored it out to this runtime. Opencl is kind of okay. We can also use cuda. Cuda has a runtime as well, and it works. Okay, let's figure out what paper we are going to implement. Image classification. Let's see, imagenet 1 GPU in an hour. Oh, our Cafe 2 based system trains ResNet 50. ImageNet train. Now anyone can train ImageNet in 17 minutes using 16 public AWS cloud instances. No, wow. Wow. Okay, we don't allow Twitter in this house. Okay, ffcv.io. Let's see what these people are doing. Oh, they just have a better loader? Simple optimized code. It seems like they're just doing ResNet 18, so maybe we should just write ResNet 18. 8 concurrent ResNet 18s. Okay. Is ResNet still really the state of the art? I mean, it's not the state of the art, but like when people are doing fast stuff, is it really still just ResNet? We should probably test it with CFAR. Do we have any CFAR stuff? Yeah, okay, good. We have CFAR. Oh, well, I already have examples train efficient net. Maybe this example is already good. No, this looks like crap. Okay, if I go into models, do I have ResNet? Yeah, I do. Doesn't ResNet use max pool? Basic block, okay. Conv batch norm, conv batch norm. Yeah, FFCV just makes pre-processing faster. There's no way ResNet 18 is the state of the art. Okay, maybe it is. This looks like a pretty decent implementation of it. Cool. This trainer looks bad. Wait, I already like have ImageNet stuff? Wait, I already wrote all this? These use torchvision transforms? Is this stuff any good? Okay, I mean, maybe we were just ImageNet class index.json. So I know you guys wanted to see coding, but there just might not be any coding. I might have already written all this. No such examples. Okay, there's nothing called train files. It's a new version that does 10 seconds. Yay, I saw this on... What net are they using? What net is this? Custom ResNet 9? Does it work for ImageNet or just CFAR? All right, let's go over to Quiet and let's actually try this. Probably not good enough to get good accuracy on ImageNet. Oh, come on. Why is there no torch vision? What's the GPU on quiet? It's a it's an NVIDIA GeForce. No, it's a 1080 Ti. I don't understand. Why are there no good versions of torch vision? I think let's go to pytorch.org. Linux, pip. We don't want CPU. We want CUDA. What CUDA do I have? 12.0. Well, that's never going to work. No, I don't actually have 12.0, do I? No, I have 11.7. All right, fine. Wait, what? This should just work. What a scam. Pip update index. Is there a way to do this? Is it because I have too new of a version of Python? Nix is a piece of shit and we will never use it. Nix doesn't solve this, okay? Nix just created a new... Do you want to download 5 gigs of an identical system next to yours? Okay, we gotta switch. Why do I have to switch? No, we're gonna make it work. Pip3 and pip are the same. Look, I tried to install Nix once, and it took up like 5 gigs on my poor little MacBook, and then it was just a whole new environment with a whole new set of problems. It's not better, right? It's you know that xkcd about standards, right? This is Nix. Yeah, we need to develop one universal standard that covers everyone's use cases. Yeah. torchvision compiles very fast. Good. All right. In the meantime, let's take a look at this code. What is it using EMA for? What is EMA? Hyper light speed bench. I mean, yeah, I think before we do, I think ImageNet was actually overly ambitious. We should probably stick with CFAR for a while. So basically, I think the game is we're going to re-implement this in tinygrad and see how fast we can make it. Why did they do this to batch norm and conv? Oh, I don't think that's supported. Maybe it is. Oh, stride is kernel size. Okay, that actually is supported. I can't believe this uses max pool. Does it actually use max pool? Or is that an option? Pool true. Okay. Fast. Why does it use max pool? Why emulate a PyTorch emulation layer? Ugh. Because then you're stuck with like all the crappy PyTorch garbage. The goal is to make it better. Like, watch how much shorter the tinygrad code's going to be for this. Oh, that's terrible. Speedy ResNet. How tiny are the CFARs? You reckon we can cut it by 40%? I'm not so sure. Are they using cuda graph or not? It doesn't look like they're using cuda graph. Maybe it doesn't matter. No, we're not writing a PyTorch to tinygrad conversion. This is the wrong. Oh, it's installed. Okay. If you want things like that, you're solving the wrong problem. Okay, you don't want that. You want a thing that is expressive, right? You want a way to code this stuff that's expressive. PyTorch is it's okay, but it's complex, right? So no, I don't want to like take all this complexity and shove it into something else. No, let's download CFAR. It's already taking more seconds. I thought this was fast. All right. What happened to 7 seconds? How many epochs does it do? This is cool. I like this code. Am I using GPU? Well, I sure hope so. Yeah. Why is it looping this? Oh, this, okay, I see. So it trains it 25 times. I see. So it's taking 20 seconds. Not bad. Now can we beat it? I don't understand what this EMA stuff is. Yeah, I know the target was 94. We don't hit 94, but we're fine with 93. Okay, let's replicate this in tinygrad. Should we do it on the? We'll do it. Should we do it on quiet? Should we do it on quiet where we have a cuda? It's a little faster. But we'll prepare it on quiet, and then we will. Cool. Let's go to tinygrad and let's make an example, and we're going to call it HLB CFAR 10. HLB CFAR 10.py. Okay. We have something to compete with. It runs in 19 seconds in Torch. I know it's exponentially moving average. I just don't really know what it's being used for. Like, I've seen that stuff used in all right. Here we have CFAR in here. Main train shebang user bin m python 3 train. Okay, from datasets import get fetch CFAR. We have to refetch it here. Theirs was nicer. It outputted nice things. Okay. But it won't have to fetch it again. I see people joining now. I warn you about this Discord. Ban. Quickly banned if you're like, you know, I just hate that shit. Like, it's like, you know, I hate when the hackernews people are like, oh, let's debate George Hotz's personality. You know? Like, fuck you, man. You can disagree with what I'm saying, but let's not, you know, what's Maslow's hierarchy of argument? Let's keep it away from bullshit, right? And there's like Maslow's hierarchy of conversation too, right? It's the same basic idea. If you're talking about things like the absolute worst trash is like the, oh, hello, I just graduated with a degree. What should I do with my life? Oh my God, nobody gives a shit about your life, okay? I certainly don't. And that's the truth, right? And you know what? I wish people would return the favor. I really wish people would return the favor and not give a shit about my life, right? Like, stop. It doesn't matter, okay? Like, you know, focus on my ideas and what I'm saying, and you can disagree with them, and that's fine. This is great. Let's disagree with them, and let's have an honest conversation. Maslow doesn't really have more than one hierarchy. It's just fake. See, look, we don't even have llvmlite. Like, it's not even available. All right. But let's just see if we actually need nicks Oh shit, we probably need cannot install in Python version 3.11. All right, fine. Okay, I'm just typing that over and over again. That's not working. Okay, let's re-implement this net. That looks like a good class to have. Class conv group. Note in tinygrad, you don't need to subclass anything. Channels out, residual, short, pool, SE. You know what? I'll tell you, it's just not really respond to that. The truth is, compassion is just going to hold you back. The worst thing you can have is someone who enables you to be shitty, right? Okay, I'll note that residual is always true, pool is always true, and SE is always true. So the only one we'll actually put here is short. From tinygrad.nn import conv2d. Oh, they just have some default convargs. Kernel size 3, padding same, bias false. Okay. I don't like that. You couldn't write that? Like you're like, oh yes, we saved a few lines, but you didn't think about. It's called comp2d, right? Got to lowercase the d. Kernel size equals 3. Padding equals. Should we support the word same? No, we really shouldn't, because like I hate that. Like it's just it hides complexity. That's I took Elon's rules and I posted them in comma Slack, and I said they're all good, and we have rule 0, which is surface complexity. Because if you're hiding complexity by like shipping things out to like a company to like, oh well, we just write the specifications for the hardware, and then someone actually said that to us. Someone's like, comma doesn't build the hardware. You guys build the specifications for the hardware, and then you ship it out to a factory. I'm like, no, like we build the hardware. Oh, okay, you designed it, but you have a factory somewhere. I'm like, yeah, the factory's on our first floor of our office, right? Because otherwise you're just hiding complexity. Someday the comma factory is going to be all robotic. And it's just going to be robots that sit there and make me money. And I'm going to be like, I own the means of production. Ha 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 ha. Suck it, communists. Okay, max pool is not actually... See, this is another... I know Torch loves to do this kind of stuff, but really, why is your activation function a class that's created in a net? Right? This right here is something that I never want to copy from Torch. There's absolutely no reason that this should be a class. Batch norm obviously has to be a class. So norm1 equals nn.batchnorm2d, and we just have to put in the size, which is channels out, if not short. We have conv2, which is similar to conv1, except it's just channels out. Conv3. Self.se1 equals, and then we have nn.linear, right? Yes, we do. Channels out, integer divide 16. And then we have the opposite of the squeeze excite layer. All right, cool. let's see. We'll figure out how to tighten this code up afterward. We also use, we don't use forward. What is forward? We use call. Okay, and then we want a max pool. So remember, tinygrad doesn't have documentation. It just has the tensor class, which is actually pretty nice to read. So we'll just do a max pool 2D. I don't like that that doesn't support single kernel size. I want to support just like the number 2 there, the same way pytorch does. I think I have a helper function for that. Do I have a helper function for that? You see what I mean? Like, I don't want to write 2, 2. I use that somewhere. It's not exactly argfix. It's similar to argfix. Okay, fine. A new helper called make pair, return x comma x if is instance x int else x. Go down to max pool 2D and do it like that. Cool. All right, now I can support that. Great. Okay, we got a pool, norm, dot gelu. We're using gelus. Is it capital gelu in tinygrad? No, it's lowercase gelu. I don't know why it's capital pytorch. Okay, if self.short, we just return right there. So I have to save short. Yeah, I guess I do. Return x. How does it say haiku? Okay, we always do squeeze and excite. So we're going to say mult equals, oh, look at this. Wow, squeeze and excite's brutal. Okay. Do I actually want squeeze and excite? I feel like I don't need it. Oh, sorry, and I wrote make pair, I think, where you can't see. No, I'm not reading. Squeeze and excite's stupid. I don't like squeeze and excite. Okay. Now we do self.conf2x dot self.norm to self.conf2 dot gelu norm 3 .gelu return x plus residual. Cool. All right, that's my implementation of conv group. Do we really want to write this? Okay, fine. We'll write this so it's exactly the same. Fine. Mult equals, okay. How do you write this in tinygrad? You say residual.mean. Dim is 2,3. I don't think we want to keep dim. We want to do self.se1 residual.mean.gelu. We do self.se2, and then that has a sigmoid around it, dot sigmoid, and then they do unsqueeze -1 twice. So I think that, do I have unsqueeze? I should write unsqueeze. Does someone want to write unsqueeze and write a test for it? Yeah, could someone write unsqueeze and write some tests for it? I would appreciate you. I should be able to just do it like this. It's actually almost cleaner. Model EMA is apparently a training trick. Okay, so this self.conv3, we throw a times mult in here. Great. I love my implementation. That's beautiful. Compare this to that. And like a lot of this has to do with the tinygrad style being kind of different, right? There's no reason that things like stateless things like batch norm and gelu should be created in the init. I still don't understand why PyTorch does this. I understand that you can use PyTorch functional and not do this, but okay, we wrote conv group. That should probably go above train. Whiten? Who's whitening? The unit hypersphere? That all looks hard. Okay, they call their net speedy ResNet, so we'll call it speedy ResNet also. In an init function, I'm going to create all these things. Okay. So I think we can just say self.net, and then for call, I can just do x.sequential self.net. And then for self.net, let's just put these in an array. Okay, we have the whiten conv. I don't know how I feel about this whiten conv. All right, let's learn about whitening. Pre-processing on the GPU, moving. Oh, these are cool. Thank you for this link. Sell you? Ghost batch norm? Oh, okay, whatever. Why is there a unit hypersphere? That's how I feel. Okay, what? Whitening kernel size 2. Initializing the first layer. A knit whitening conv. Eigenvalues and eigenvectors. Okay, we got to draw the line somewhere, guys. And it said eigenvalues and eigenvectors. What's depths and knit? All right, self.conv. We have the input conv. Input conv goes with 3. Weight equals false. How do I feel about that? That there. Okay, we're definitely not doing this. We have to draw the line somewhere. I wrote squeeze and excite. We're not gonna do this. We can't do this. That's crazy. Whitening's crazy. Look at how much code there is for that. Okay. Base depth is 64. All right, so their init conv is 64. All right, fine. Yeah, they're right there. They just misspelled scalar. Okay. It's not self.conv. What am I doing? It's nn.conv2d. Those things. What's our initial kernel size here? Kernel size 1. That's fine. Gel you. Now we put in these comms. 64, 128, 128, 256, 256, 512. What is this fast global max pooling thing? I have an idea. It's just x.max. Yeah. Okay. Max 2, 3. Then we're going to do a linear from 120 to num classes, which is 1000. Bias equals false. Does my linear layer support that? If it doesn't, it should. Yes, it does. Okay, bias equals false. That's good. And then temperature, which we don't have. Great. Can we just point out how much shorter this? I think this is an implementation of the net. I know I didn't write the whitening, but still, like, this is what I mean about I don't want to write a stupid translator for PyTorch. I want to do better than PyTorch. Right? I don't want to write like that sort of garbage. And then also I want to do this, right? Let's just do this. Oh, no, that's slightly wrong. Right? Beautiful. We'll let non-subscribers talk about how beautiful this implementation is, if it works. You think it works? You know what the worst question in the world is? It's, can I ask a question? Not only did you already ask a question, it was the dumbest question in the world. That's actually the dumbest question. Hello, can I ask a question? It's like Godelian in the way it's broken. You just asked a question. Yo, I saw a fire tweet. It was like, can we talk about how George Hotz deleted all his tweets and tweeted an image of the Joker saying, who wants to do AI dangerous? This isn't a man I'd trust with the fate of the world. I wouldn't even trust him with my kids. I really like that tweet. I posted on my Instagram. Oh, the best is, you ever text with old people and they like sign it? Like, hope you're having a good day, -- mom. Favorite TV show. All right, you're the reason we're going back to subscriber only. Is tinygrad actually fast with CUDA? Yeah. I mean, we're going to see. It's not, look, it's not going to be as fast as this. This is a hyper-optimized, like, it's a really unfair thing to compare against. We should really compare against, like, a normal torch implementation of this. Yeah, I don't understand why they think we're trusting you with the fate of the world either. Exactly. That's the funny part. Because I tweeted a picture of the Joker. You know, like, oh my God. The whole Twitter saga. It's just, it's absolutely unbelievable the way, like, and everyone says this who reads the news, the way the internet just gets things wrong. And you have the inside view, so you know how, like, laughably wrong this is, but you know what I'm saying. Yeah, we don't have to download stupid torchvision either. Okay. All right. I think we can just train now. Is that right? Is it gonna work? To do. Add whitening. We're gonna learn about whitening. We did a Jai beta. Is Jai released? code in it? Why is my internet slow? Should we rewrite tinygrad and jai? No, if I have to get a beta, no, it's not ready for me yet. Okay. Net.to, net memory format, torch channels last. We don't need that in tinygrad. Okay, from tinygrad import nn.tensor. Where's my trainer? I have some generic training code in here, don't I? Extra training. Is this gonna work? From extra import training. And then we can say train model xy. Oh, we need an optimizer. Yeah, we need to create an optimizer. Okay, what optimizer they use? Atom? Not Atom, great. SGD, all right, easy. I guess SGD is fast. Okay, optim equals nn.optim.sgd. Create the optimizer with model, I think. I don't know, let me find like an example where we actually train something. No, it's wrong. We have tests that train MNIST. Let's just look at them. Okay. nn.optim. I'm not sure nn.optim is going to work for some reason. Do I not? Oh yeah, I don't think that's going to work. Okay. Tinygrad import tinygrad.nn import optim. Where's tensor not work? Oh, it's from tinygrad.tensor. Wow, if I can't even use this, how could anyone else use this? Oh, and then we shouldn't call it optim if I import it as optim. What do I call it here? I call it optimizer. All right, fine, optimizer. You pass in model.parameters, but that obviously doesn't work. Oh man, am I allergic to this sweater? I'm allergic to this sweater. We're up to change sweaters. Alright. We're changing hoodies. This hoodie's a little ripped and I'm upset. I tried to climb a fence and I ripped my hoodie. And see, now it has a hole in it. But I bought a sewing kit off Amazon, so we're going to try sewing. Alright. We've got parameters now. We're just going to pass it into get parameters model. And there's like a good reason why you need all this stuff. Okay. We pass in the optimizer. And then how many steps? How big is CFAR? What batch size do they use? That's a real thing we can find. Batch size. 512. Okay, cool. BS equals 512. Loss function's fine. Everything else is fine. Oh no, we have to pass in steps as well. Okay, for steps, we're going to say x.shape sub 0 divided by 512. I should really add. Oh no. What am I doing? That's fine. Okay. Did we do it? We don't even need tensor. This training stuff should probably make its way into official tinygrad. Like how 642 lines, 53 lines. The only difference is my code doesn't work and it's way slower. But other than that, it's way shorter. So you have to give it some credit for that. It may be wrong and slower, but it's short. Steps is not defined. Where did I use steps? Did I try to like save that or something? Yeah, okay, saved garbage. All right, we added make pair, that's fine. Let's go. Conv group requires one positional argument, short. Oh, I didn't put in short. We're gonna say short equals, oh. Only the middle one is short. Train got an unexpected keyword argument, steps. But I have steps here. Why is that unexpected? I'm allowed to use keyword arguments like that, right? Yeah, we'll get rid of it, fine. I don't get that. Oh, no. The problem is I called this train. We'll call it train CFAR. Can't call two things train. That's too much train. You can't have too much train. Okay. Speedy ResNet has no attribute forward. Oh, really? Really? I hate that it's forward. It shouldn't be forward. Why did I call it forward? I copied that from Torch. It's stupid. It should just be that. None type has no attribute shape. Did I not return sequentially? Yeah, I got to return. All right. 19 steps. Okay, CFAR is tiny. Does CFAR have an evaluation set? How does the real code do it? Oh, well, okay, now it's training on the Could someone also please add a test for that new make pair thing I did? Actually, I'll just do it quickly. Let me just do it quickly, because if I don't do it, where do I test max pool? Test max pool 2D simple. We should also just add in 2 and 3 here. Great. Make pair and first attempt at HLBC 410. Now we figure out Pyland, Flake, MyPy. Good. Okay, let's try this. GPU equals 1. Opt. Oh, we're gonna have to put caching around it. Should we just write the jet? We should probably just write the jet. We don't need to set opt. We would like to set debug equal to 2 so we can see what it's doing. All right. It's running stuff. Okay. Now the loss is going nan. It's probably going nan because that stupid squeeze and excite, which, may I remind you, I hate. No, that's not why it's going down. Whatever, we'll put it back in later. Let me see how they wrote that to actually have that as an option. I do kind of like that as an option. I just find that more readable. Like, I'm not even doing that for lines. I actually just find that kind of code more readable than like this kind of stuff, because you have to read so much. Like this, you just spend a bit of time on each line. You're like, oh, okay. It's creating the same conv, checks the range, does the first one. Okay. Why is the loss going nan? I set training to true. Oh, did I not set training to true? I don't think I set training to true. No, that sets training to true. Never mind. Okay. Why is the loss going nan? It's not related to the squeeze and excite because I disabled that. See if any of the ASTs are wrong. Unable to allocate 144 gigabytes. Okay. I mean, that looks like reasonable. Why am I getting nans? All right, let's try a batch size of 16. I don't have much hope for that, but whatever. Okay, doesn't go nan anymore. Takes longer to go nan. What's happening that's going nan? There's nothing weird at all in this net. I write something wrong? I mean, those shapes look very good. There shouldn't be anything wrong with GelU. There shouldn't be anything wrong with maxpool. We're not using this. What did I do? This looks like a very simple net. Oh, could my learning rate be wrong? That probably seems like the most likely thing. I didn't set it. What is the default learning rate? Seems somewhat reasonable. They're using some cycle. I don't know. Let's just use Atom. Does anybody trust SGG? Not me. Mans. They had a more stable example attached to comments here. Oh, out of memory? Oh, they changed the batch norm momentum. Yeah, so they changed that. It shouldn't really matter. They did something with the batch norm momentum, right? Oh, EPS is tiny. Batch norm momentum equals 0.8. Okay, that's an insanely high momentum. Or it might be the opposite. Weight equals false, bias equals true. But I didn't even know it supported that. No, none of that explains why it's broken. That's not even running. Really, I just want to take it out. Like, I just don't like it. It's bothering me just being there. Can we take out some layers? What layers? There shouldn't be anything wrong with GelU. I mean, we can try changing that to RelU. Oh. Okay. GelU is not a chill activation function. There's probably something wrong with my implementation of it. All right, we can put squeeze and excite back in. Don't need this crap anymore. Fine. Put the batch size back up to 512. Oh, let's figure out what learning rate they used. They probably use some crazy high learning rate. Max LR. I don't know. I don't trust that. We will make the learning rate explicit here though, because I forgot all about it. If you don't make it explicit, you'll forget. All right, let's go. Why is the accuracy 0? Oh. Does CFAR have... How many classes does CFAR have? I assume CFAR 10 only has 10 classes. Num classes. Yeah, 10. Okay, well that's a problem. CFAR only has 10. Why is JLU broken? It's a large batch size. And now we also want to use the cache. I could just add the cache in here to the trainer. This is so slow. It's just painful. All right, let's make the batch size 256. That's a good compromise. We're gonna have to take this trainer out. We're gonna have to. No, we got to do apples to apples. Batch size is 512. Everybody knows the batch size is 512. Don't try to lie about other batch sizes as a scam. Okay. So which one of those is time? It takes about 2 seconds to do an epoch in PyTorch, and it takes 1 minute to do it in tinygrad. Don't worry. You haven't even turned on the optimizer yet. And I'm sure that train code is super unoptimized. This is using NumPy? Ew. Oh, do I have to put a log softmax? How did this not do a log softmax? Where's my loss function? CrossEntropyLoss. Label smoothing? Yeah, no, we got to put a log softmax on here, I think. How come this one doesn't have a softmax? What is nn.CrossEntropyLoss? Does this include a log softmax or something? Between the input logics and target. Oh, this case is equivalent. I see. We need to add a log softmax. Yes. I'll just add that down here. It's not going to make it faster, but it is going to make it more accurate. So this gets a train accuracy of 54 by the end of the first epoch. So let's see what we get to. Also, where's my val set? How do they get a val set? We need a val set. Train equals false. Datasets.py. Data batches.1. Let's put other files in this tar file for non-train. Why is my accuracy so bad? And I'm using Atom. Can't wait till we start optimizing. Oh, we'll optimize. Don't worry. Okay, right now we're off by a factor of 30. But first we got to find out why there's bugs. I don't know. It's 10x the learning rate. Looks like it diverges. The loss is going up. That's not good. I don't trust this large batch size. No, we have that in the trainer. 0 grads here. We gotta figure out how to get the training set. TT extract file. Wow, that's not even all the training batches? Wait, so you're telling me that this is running it? Never mind, we might be off by another factor of 5, which is just brutal. As well as test batch.bin. Training also has evaluate. Why do I need to tell it num classes? For some reason I do. Whatever. We're using opencl, but that's not the problem. Well, we can optimize. We'll run the optimizer in a minute. We're not running the optimizer yet. Num classes. Oh, okay, I don't really need to set it. Wow, that's brutal if that's true. Is it actually that anymore? Okay, let's run the optimizer. The optimizer is slow, I warn you. Just the first time now, then it catches it in a second. You can read the optimizer. You can read so you see how much speed up we're getting on these things, on the kernels. This is like each kernel that it's running, and then that's how much it's speeding it up. Wow, that kernel's so slow. The kernel was taking 11 seconds. All right, there you go. It's a lot faster. It's about twice as fast. Still, this is so fast. Are we utilizing the GPU? 82, 56, pathetic. Pathetic. Okay, the problem might be how we're copying and we didn't use tinygrad jet. Oh, the problem now is just tinygrad jet. Oh, more forward crap. Have I checked out Open Assistant? Is this a real thing, or is this a bunch of people promising to have something? Well, Lion's pretty legitimate. Is it good? Read the first pointer of their plan. Seems very bad. Where? Oh, the thing about like putting the human first or something? Yeah, you just need to like, I don't know. We put the human in the center. Yeah, you just need to like read past this garbage. Like it doesn't mean anything. I don't know. Someone was talking about, I saw a hackernews comment about like comma.ai's safety principles. Wow, it's so sparse and minimalist. Like, let me show you the Waymo safety page. Let me show you the comma safety page, right? So, like, this is, I hate this so much in the modern world. Like, fuck Waymo, and this is, like, safety is at the heart of everything we do because safety is urgent, TM. Like, I hate you. This doesn't say anything. This doesn't have anything to do with safety. At Waymo, we are as rigorous and innovative in our safety practices as we are with our technology. We've built a fuck you, what is it? Right? None of this stuff has anything to do with here we go. Here's the Waymo safety report. Our first thing is our mission. We're building a safer driver for everyone and a stock photo of a 6-year-old kid. Fuck you. Like, this isn't okay. No, and someone needs to be told that this isn't okay. And like anyone who sees this kind of shit needs to just be told, this says nothing about safety and you're killing people, right? I really mean it. I really mean it. This kind of shit is killing people, right? It's killing the future. It's killing the world. It's bullshit. Okay, compare that to commas. We've been seeing questions of modifications to opencl violate our safety model or not, right? Now we already have a documentation described, well, okay, the link's broken. It is in there. It is in there. We just moved it. It's in docs.safety.md. Someone should update the link. But the driver must always be paying attention. The driver must always be capable of immediately retaking manual control of the vehicle. The vehicle must not alter its trajectory too quickly for the driver to safely react, right? So, you know, this one obviously involves the driver. Like this is a safety model. Right? And you can have a conversation about this, right? You can say that, like, maybe this isn't enough, right? Like, maybe we forgot something. I don't think we did. I've spent a lot of time thinking about it. This is bullshit that you can't engage with, right? And it shouldn't be okay. It shouldn't be acceptable. Right? And then, like, this is, and then there's someone on Hacker News saying that they prefer this garbage. That they prefer just empty statements about how safety is important to these people. Right? Look, there's pedestrians crossing while our Waymo waits for them. I hate you. All right, test set accuracy is 0.1. That's not very good. I don't know. Should we try Atom? I also broke Atom yesterday. Actually, I didn't break Atom in general. Yeah, comment has actual information. You can engage with it. You know, it says something, and you can disagree with it. If you can't disagree with it, you're not saying anything. It should definitely work without squeeze and excite. We don't need that. All right, should we write the JIT? You asked a keyboard question? Oh. Let's check matmul. Don't worry about matmul. It's not matmul. Like, my matmul is slower, but it doesn't really matter. You're so far, like, matmul is the thing that's been hyper optimized on GPUs, but you're not getting anywhere near the real number of flops. So it's irrelevant. All right, should we write tinygrad.jit? You just use one output and one thread. Yeah. So there's a lot of stuff we can do to improve the actual, like, the meta code here. So we'll get there. Let me just write train step jitted. Train step jitted looks something like this. Wow, it's using forward. I hate forward. Okay. Model X tensor dot training equals true. From tinygrad dot tensor import tensor. We can't use the generic. The generic training code is slow. We'll read fast training code in a bit. Okay. Oh. This put log softmax there. How do I feel about that? This didn't. But that sparse cross entropy is so slow. Look, it's creating that. Oh, it's so slow. No, and X isn't even right here. Okay. Well, okay, this is fine. We just need to be careful to create it here. All right, let's call this X train, Y train. We don't need the test. Pick the sample, tensor, import numpy as np, bring BS up here. Tensor equals X train subsamp. We'll say as X, Y equals Y train subsamp. Y equals Y dot flatten. Yeah, like this is slow. Opt is different. Opt is for the lazy thing. Yeah, we're gonna have to write like good versions of all of this. This is very slow. Okay, let's do this correctly. The file shape should just be BS num classes, right? This doesn't even need a flatten. This is way overly complicated. Range bs sub whitetrain.samp that'll work. Object, oh. Okay, cool. That should work. Yeah, we'll have to like multi-thread the shit out of this. All right. Now we can do train step jitted. And to do this will become at tinygrad.jit. We say jit equals false if no jit. We run the model for x. That's out out.mul y.mean. That's loss. Zero grad loss dot backwards dim dot step should be right. Zero grad. Oh, we're not going to call it optim. We're going to call it optimizer. Okay, we should benchmark these things, I think. Loss realized, it's not really right. We have parameters realized. The optimizer should do that, right? I think my optimizers actually do realize the parameters. Yeah, they call realize down here. Okay, so they realize the parameters, so we don't actually need any of that. Okay, if not JIT, we want to save the cache. If I equals 1, cl.cache equals that. We have to import CL. So cl.cache will make it actually not run, and we'll just output it into the cache. And I kind of do want all this stuff. I'm going to cache it, and then if it's cached, we run that. Should be good, right? So this should be like just part of a jet, and that should be the return from that. Yeah, so I'm actually going to move some of this stuff out. Hang on. And we have something called global counters, so we should just be using that. Global counters, global ops. We want to set global ops to 0. That still gets incremented even if we're caching, which I don't really like. That's fine. Just runs it through the cache. So it actually runs it twice, which kind of sucks, but okay. So we're going to move this down here. We're going to say loss equals here. Here we're always just going to say return loss. We're going to move this stuff down to here. Put ET here. We don't return that. Ops, global counters dot global ops. That's what we're going to plus equals in this tight little loop. That all seems good. If we're caching, I don't actually want to increment that, but I feel like I increment that in ops GPU, which is kind of too bad. Yeah, see, I increment it here, which means that that's actually going to run it twice. Let me write this a little differently. First equals true. Okay, if it's first, I just want to run it normally. If not first, equals false. And then here we'll just run this. If not first. Should be right. No, I want to run this if not first. No, that's not right. If CLCACHE. I can't do an else there because I do want that to run on the third step. Okay, let's try that. And we don't need to optimize it for right now. Okay, cannot access variable first where it's not associated with a value. I love the new Python errors, by the way. We can't copy something to that while we're caching. Just comment that out for now. Okay, so we see about how long it's taking. It actually, I'm not even sure the cache is really going to help because so much time is being spent in CL. The runtime can be made faster with the cache, but nothing else can. Either way, if we get faster runtime, that sounds good. Why is that failing? That's failing because we didn't realize X and Y. Oh, and then... There's a lot wrong here. What is CL? So CL is the time that it actually spends. So this is going to force the CL queue to actually be realized. This does a blocking copy when we copy it to the CPU. If we don't do a blocking copy, oh, here's another fun thing. I'm not sure how bad it's. Oh no, this isn't going to work. Because I'm on the wrong computer. Okay, that's how many gigaflops we're getting. That's a somewhat reasonable amount of gigaflops, do we think? I don't really know. Let's see if we can fix the cache. Don't want graph. Okay, cannot copy while caching. Oh, because that should not be in the cache. How is that in the cache? That definitely. Cache should be turned. Oh, okay. If not first, and then cl.cache equals none. Let's try that. Great. Okay. Notice how run now, instead of taking 102 milliseconds, only takes 2 milliseconds. This isn't the problem because we're spending so much more time in CL, so we won't try to debug two things at once. Okay, we're taking 700 milliseconds to do a step right now. I feel like this thing is doing steps unbelievably fast because those are epochs. I don't even know how many steps that is. That's insane. I kind of feel like we should just give up. This is way too fast. This is way too fast. This is insane. Okay, it's doing 96 steps. Actually, 97. It's doing 97 steps in 2 seconds. With big batch size, with a bigger batch size than me too. Yo, guys, we should just give up now. This is too good. Does it work? I'm not even worried about that yet. We'll get there later. I mean, does it work? The loss is going down, so yeah, it works. It's taking 800 milliseconds, and that takes 20. So we are off by a factor of 41. Great. With the optimizer, we're only off by a factor of 20. But it also seems like the optimizer is wrong because the losses are different. Guys, this is hopeless. This is so hopeless. The losses are different with the optimizer. I mean, it is the kernels. I'm not saying it's not the kernels here. You want to try the CUDA implementation and see if that's faster? I don't think it will be. Oh. I shouldn't even really be using CL. Invalid argument. Great. Well, that's an interesting thing for someone to debug. Oh, that's... If we want to have the mem used, we can't use CUDA. That should really be a global thing. I'm going to move that global. Where do I make cl.mem used? It's in the opencl repo. Yeah, we do actually want that there. I mean, it's definitely the kernels. Okay, so we can see the kernels. Want to see the kernels? Also, what's even sadder is they're doing this with a batch size that's this much bigger. So we're actually, no, never mind. We're off by way more than that. You guys, this is hopeless. To be fair, our target is not NVIDIA. Our target is the M1. And the torch on the M1 is pretty bad. Brutal. Brutal. Because that is the batch size they're using, right? This code's so good. Bro, look at what they're putting through the network. The link you wrote gets to 80% of theoretical speed. Which link? Well, we totally aren't ready for ImageNet yet. We have a lot of work to do. It's so fast. That's insane how fast that is. All right. CUDA MMM. Yes, I understand, but we will include this. I'll add this to the top of the file. But again, like, we're not doing matrix multiplies. We're doing convolutions. This just seems to be super optimized, and if we can get even close to this, I'm so happy. Because, okay, the idea of tinygrad is not to give you the highest end performance. It's to give you good performance in all cases. Like, you shouldn't really have to think about performance. You should be able to write very simple code and get high performance. And the back end will deal with everything for you. Sadly, we are so far off. Well, I can show you the kernels. So there are a few cool advantages to tinygrad, which is it's easy to actually print out the kernels that are running. And we can look and see how many bajillion microseconds these things are using. I also want to do, I kind of like do this stuff here. cl.time sum equals 0. This should move to global ops. Okay. And actually, I really want to set kernel count to 0 too. Let's see if we can safely do that. Yeah, there shouldn't be a problem with that. Where do I set that initially? Oh, it's in here. Okay. So it's doing 133 kernels. Why are those not fused? That should be fused with that. Well, that's an interesting problem in and of itself. Those should be fused. I mean, it's not like it takes time, but still, that shouldn't be there. See, this is just bugs. Okay, so this here is a single convolution. That's the reduce. Wait, I don't understand what that is. Never mind, this convolution's weird. But all of them have this. So for some reason, this isn't being fused with this. And we can start really trying to dive into why. We're running training, we're running backwards. It probably has something to do with that. Probably has something to do with the backwards pass of the batch norm not being well written. So we can get the number of kernels down. So it's doing 133 kernel dispatches. Now we can also look, these are the backwards kernels. The backwards kernels are getting a terrible amount of gigaflops. Like this GPU should be, and this isn't even including tensor cores, which we'll get to. We'll get to using tensor cores, guys. I don't know if is that possible from opencl? Tensor cores are now used efficiently. What is this? You can use PTX inline assembly in opencl. Oh, that's sick. Yeah, I mean, we're going to have to use tensor cores. There's no way that... Well, let's see how many ops the network is. I want to reset the op count to... where is that printing? Oh, cl.opsum. That just shouldn't be there. We have a lot of refactoring to do. But okay, now we're going to get a real opsum. So we can see down here, it's doing this many giga ops, and it's doing this in 2 seconds. Wait, that's like not even good. It takes 2 seconds to do that? No, that can't be right. No, never mind. It takes 20 milliseconds to do that. Okay. So their step time is 20 milliseconds. So 20 milliseconds per step. If the step is this many ops, What's this divided by 20 milliseconds? 20 milliseconds is 50, so just times it by 50. 58 gigaflops, 58 teraflops. Wow. Wow, this code's unbelievable, guys. We're getting 58 teraflops. They're not using CUDA graphs. They're just getting straight up 58 teraflops. Yeah. We can talk about why that is. Wow. All right, now it's doing the copy ins. I'll put the optimizer back on. But the optimizer is giving me wrong code. So this is actually running the optimizer right now. You see all these? It's like trying all these different permutations to the kernel. So they're also using float 16. Wow. The loss scale scalar. Guy wrote code this fast and doesn't know how to spell scalar. Okay, so there's several different levels we can start optimizing at. We can start trying to figure out why the fusion's broken. It's always an interesting idea. We can try to figure out, we can try to do, it's going to require some hand optimization, but we could figure out how to use the tensor cores. We could add support for float 16. That's only a 2x. We're so many orders of magnitude off, guys. Should we just give up? Is this just give up time? I feel like it might just be give up time. It's so much faster. $58 teraflops. I've never even seen a number that big. And that means some of the kernels have to be getting more than 58. 58's the average teraflops. Okay, the tensor cores do have unbelievable performance. All right, we're doing a little better. We get about 2x with our optimizer in exchange for it being wrong. What's the theoretical max? Well, that's a good idea. That's a good question. It has 320 tensor cores. So it has to be using the tensor cores. I mean, that's not... floating point 16 doesn't even seem to make it faster. G flops per tensor core. Okay, the A100 is 300 and 712 tensor flops. And how many tensor cores does it have? Maybe we can just divide. Four tensor cores per SM. Okay, how many SMs does it have? Each SM. No one's ever beating NVIDIA. Oh, it has 128 SMs with 4 tensor cores per... Oh, wow, it has a lot more tensor cores. No, wait, this says 422 tensor cores. And this has 320. Isn't that a different architecture? No, they're both Ampere, I believe. Yeah, they're Ampere. They're the same. Oh, there's a poll, I see. How to use tensor cores. All right, we're going to use tensor cores. Damn it. Oh, we also have a question of why the optimizer is broken. It seems like a lot of the slowness is on the backwards pass. Oh, these aren't even... Okay. This is the first real convolution. These convolutions, they cannot be this big. All right, I guess we're going to look into how to use tensor cores. It's all on the table at Tom's Hardware. All right, Tom's Hardware, T-flops. Is it really? I don't think you're right, but maybe you're right. Oh, you're totally right. Never mind. I like you. You're good. Tensor. Wait, I don't really believe this, though. Why is it in parentheses? I think this is the float 16 and this is the TF32. So at float 16, the theoretical maximum is 273. Oh, it's a sparse scam. I see. Okay. So it's sparse. I see. What about tfloat 32? This supports tfloat 32, right? For at half the speed? No, you really don't want me to support float 16. No, we're not supporting float 16. Guess what? It's not a democracy. Float 16 is stupid. With sparsity. Let's turn off. Actually, I should just be able to turn off float 16, right? Let's just turn that off. How slow is it? Does that work? How to use tensor cores wins. Thank you. Thank you. We're going to look into tensor cores, right? Tensor cores are way better. Oh, you voted with channel points. Oh, I see. All right, we're going to look into how to use tensor cores. But first, we're going to figure out where's this half stuff coming from? Let's just use amp. Let's just use apex. It's nice code. X.float, float 32, float 32. That's fine. That's all fine. Where is the half coming from? The inputs. Oh. Could these actually need a float? I think it's putting all the data on the GPU. Input type is that. Bro, I don't care if you had every channel point in the world. I wouldn't talk from my fucking keyboard. Alright. I don't get it. What the hell? Forward call net inputs. Get batches. Something here converting it to half? How's that float 16? Whatever. Let's read get batches here. Data dict key images. Batch crop. Torch mask select. Oh, no, that's right. Oh, ha 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 ha. We'll just hack this. See the problem? This is saved. Okay. It's still pretty good. It's about 4 seconds. Actually, I assume that's TensorFloat 32. We can disable the TensorFloats. There's a parameter for that. NVTF32 override. If you don't do that, it's silently... So then it's not actually float 32, it's TensorFloat 32, which uses the tensor core. So now this new one's not going to use the tensor core at all. Okay, now we get that. give it one more, because it's about 6.4 seconds. So if we get 4 seconds, 4 divided by 97, let's go back to this. 2 divided by 97, if that's 2 seconds, that's milliseconds per step. We want to take this and divide it by that. So that's 56 teraflops. Teraflops, and then if we don't use, if we put the override on, we get 17 teraflops. Okay. So we don't look as far off when we're doing the other stuff. Just to, okay, so this is, each one of these is about 50% of the theoretical, it looks like. That's an amazing card. It's actually super high. It's way higher than I thought. That's insane. It's exactly the same. So I guess we're not memory bound at all. Basically 3090 with less VRAM. Yeah, it's really good. Okay. So we're getting, I mean, that's cool. We're getting 50%. See, look, tinygrad was already useful. We computed the number of, oh no, wait, we're not even doing the whitening. And we're not even doing the squeeze and excite. Oh. So it's even worse. How many ops does that add? It probably doesn't have any ops. I don't think that's much. It's like the same. It's actually less. I don't know how that can be less, but whatever. Is that number just wrong? No. Is it less with squeeze and excite? So you can see these ops here are the ones that are actually like creating the weight matrix, and they're pretty slow. We're still orders of magnitude off without even touching the tensor cores. So we have to figure out why. Like until we can get closer, there's no point in trying to play with tensor cores. Well, bro, this is just brutal. How demoralizing is this? Demoralizing, guys. It's demoralizing. cheating a little. You can get rid of something else from Torch too. Does tinygrad work on ARM? Nope, it only works on x86 Python. We hand-coded crap to make it only work on x86. Of course it works on ARM. Oh yeah, what did I want to disable? Oh yeah, at the last, channels last. Yeah. It's even faster. Wow. The whitening is the speed up. Where's my T-flop calculation? Not there. I don't know what my T-flop calculation is. Whatever. Whatever. It's so fast. Okay. Guys, I don't know. It's too fast. It's too fast. That's without even using the so we get 50 milliseconds basically. All right, so we are off by all the time is being spent on the GPU. So you can see the ratio here of this to this. This is the actual like GPU performance timers, and you can see that all the time is actually being spent on the GPU. Only 64x off. All right. Well, we're off by 64x. How are we getting a 64x speed up? All right, so I can start to show you guys some of the tinygrad debugging tools. Then it's nap time, and then we'll go back to this. We're getting there. We're getting there. We're only 64x off. And actually, the way that we made it faster was actually just to make the pytorch slower. So, you know, if you can't succeed, you don't have to be the fastest guy running from the bear. You just have to, you know, like invite your slow guy. You know what I'm saying, man. It doesn't matter if the bear gets caught in the bear trap. If another person gets caught in the bear trap, that's cool too, man. Bear traps work both ways. That's right. Just copy and paste it into Google Sheets. Google Sheets. Okay. AST print. Ready? We worked really hard on all these great debugging tools so we can make it fast. AST print equals that. Did you print the AST or it's print underscore AST? Oh, I gotta love how I don't remember my own. I forgot module. What's module? There we go. I printed the AST. Okay, this is the code being generated. And we can just go here and take a look at this. external test GPU AST, test cfar conv. Test external test GPU AST, test AST dot test cfar conv. Okay, it works. That's good. Huh? Oh, I forgot compile and test AST, so it actually just did nothing. Okay, well, it's unable to allocate a 144 gigabyte array. That's a shame. I'll just need our test equals 1. It's fine. All right. We are getting 1.8 teraflops. Okay? This needs to go up to at least... where am I? Let's just do this math again quickly. Sorry, I forgot. $24 T-flops. Okay, we need to get this to 24. Okay, so that's only 12x off. That's not too bad. That's only 12x. Let's throw the k-opt on there. That should optimize, right? Did it optimize? Maybe that doesn't optimize. We should add k-opt here. All right, this should actually go in the optimizer. Let's move that there. I should call this apply. So it does actually apply it. All right, now we can can say if int, this all needs to be refactored. I can't just keep spamming os getenv everywhere. That just needs to be a helper. That needs to be refactored. Man, someone want to refactor that? You want to output a 4x4 matrix? We can do that. We can do that if you think that'll make it faster. There we go. That's outputting a 4x4 matrix or something. Oh, good. It's twice as fast. Look at that. No, it's not outputting actually a 4x4 matrix. It's batching them by 8. But if you want to allow multiple interventions, we can do that. It's searching for better optimizations. Okay, it did an 8x8. Oh, look at how many G-flops it's getting. Hell yeah. That's pretty good. Okay. 15 teraflops. That's a good number of teraflops, boys. Should we allow more optimizations? And allow swaps. Might even get faster. See, sometimes it hits a bad one and search is so slow. That's only upcasting to 8. We can allow upcast to 16. All right, good. But look, by doing it 8x8, is there a way to look at the PTX output? We could. Wait, 16 G-flops. Why didn't that one accept 16 G-flops? It's probably because we don't allow enough. I can fix this. I can change that to 0.95, and that will allow the 16 G-flops, I think. Now, unfortunately, the optimizer outputs wrong code sometime, which is a tragedy. We at least shouldn't waste time. If one is that slow, we shouldn't run it 3 times. Okay, but it keeps finding those same 2 upcasts. Oh, it finds another upcast. Makes it even faster. Oh, we're not testing the AS. 20 G-flops! Yo! Now, this might be wrong, which is also kind of annoying. What's the aim of tinygrad? Well, is that a why question? What are the goals of tinygrad? To conquer the world, okay? The same thing we do every night, Pinky. Wait, it's like still doing upcasts? How is that faster? The same thing we do every night, Pinky. Try to take over the world. Okay, it's still spending, that can't be right. It's spending 3 seconds on this single conv, and that's good? No. No, that's microseconds. That's not, okay, that's just a bug. Those aren't actually, those are US, those aren't MS. Yeah. I think that's just printed wrong. Yeah, okay, divided by, yeah, it's US. Okay, now we're spending 3 MS on the one kernel. That's good. This is insane. It just upcasted everything. No, this is probably wrong at this point. This is just getting stupid. Yeah, okay, maybe we don't actually want to allow swaps. Swaps just make it slow. It didn't actually choose any swaps, it just chose upcasts. We have this thing where we print at the end, right? Only if we do that search. Either way, we can just look. What did we go from and to? We went from 38 milliseconds down to 5 milliseconds. Okay, this is the right order of magnitude. This is good to know. And then we can make it even faster if I get rid of this and change it to that. But then I think the answers might just be wrong. It does find a few more. See the interventions here? These are the upcasts. Oh, it's brutally slow. We have to wait for the bad interventions. If it's bad, it should just bail quickly. I think these are just wrong too. I'm sure they're wrong. Yeah, we need to work on making sure that the optimizer can't be wrong. But it seems plausible. At least it's doing the right amount of arithmetic. It's possible that the look at these kernels. This is the winning kernel that gets lots of G-flops. I mean, you see why it's good, right? These are reading the weights. I bet this one's actually correct. Unfortunately, we can't check because it allocates way too much RAM. I mean, yeah, we could replace all that with a PTX instruction, but do you really want to do that? That's boring. All right, so then those are all the stores. This is probably slow as well. Ew, like that's terrible. Oh no, what's 512? So it probably just shifts. You want to see? Oh, you want to print the PTX? Oh, yeah, we should be able to do that. Okay, let's try to do that. Let's try to do that. Well, I'll notice that we only get this when the cache isn't hot. That's a non-hot cache, but still, 13 teraflops? That's a fuck ton of teraflops. Let's go. That's a all right. No. That's a respectable amount of teraflops. I mean, it's a lot more teraflops than we had. So you see what it's doing. It's not doing anything very sophisticated, and I actually think this code is correct. So yeah, it's vectorizing basically. And what it's doing is it's increasing the arithmetic intensity. So now it's really 8 by 8. So it's doing 8 wait reads and it's doing 8 real reads. And there's probably some ways to make this a whole lot better without this stupid validity check every time. I think that's just unnecessary. Oh no, those are the end validity checks. Okay, oh these are the Y validity checks, and it has to do X validity checks here. Wow, the symbolic code's pretty good. That bug you found in symbolic, Jackie, is kind of, we can talk about that. What should minus 1 mod 10 be? Right? Does anyone know what Python is going to give me here for minus 1 mod 10? Does it do 4x4 matmul already? Well, it found that 8 is faster than 4, but actually there's a chance that 4 is faster. Let me turn off the cache and disable the use of 8. And we'll see if it finds 4. I mean, the search is greedy, so it's possible that 4 is generally winning. That's pretty much crap, hang on. It just finds more 4s now. And I actually think at that point it's no longer correct. I don't trust this. You want to see a, we're going to print the PTX. We'll get there. I don't exactly know how to do that. Let me just get it back again. Let's turn the CLCACHE on. What? That's what Python returns for that? I thought Python was going to give me -1. There's definitely an argument that it's -1. Did older Python give -1? It's C that gives -1. Okay. Yeah, there's an argument for both. Yeah, I know about the integer division. So this is what's confusing in symbolic. There's like a right way to do it. I don't think any of the symbolic code is wrong, but that's why you're struggling with your test. This one. Wait. Why do you expect rep min to be 1? No. Never be bigger than min and max of the Boolean var. But I appreciate writing tests for symbolic. Tests for symbolic are great. Okay, we want to see the PTX be printed. I think we can do that. We'll put it in as debug 5. Eight by 8, okay. There's like a way to get the binary out. I do this in need. This might not be the PTX, this might be the SAS. I can definitely do this. Unfortunately, we can't use the optimizer with CUDA. It shouldn't be prog. What? There's another way to get that. Hang on, I have it in need. Binaries. Prog is saved in CLCACHE. I think that's CL prog. Has no attribute CL program. It's just CL program. There you go. Hang on, I have code for that in... Oh, I didn't merge it. Is that actually a string or is that a... I'm gonna have to like eval it. No, that's good. Okay, there's a code. So it loads them. It does a whole bunch of FMA RN32s, which you think maybe they should be. No, but none of them are. Like, you think they should be float 4s, but none of them actually are float 4s. FMA looks boring. I mean, there's your kernel. When I think tinygrad will be done, it doesn't convert it to tensor core instructions. Yeah, I might have. It's only there. I mean, it can't convert it to tensor core instructions because it's float 32. There's float 4. Yeah, let's read PTX and see. What is this RN? Well, I think these things are the tensor core operations, I think. What the picture? This picture, there we go. Oh, it's doing a multiplying reduce. No, that's a lot more okay, we can't actually use a tensor core the way that we're using it. It will eventually improve itself. That's true. Someday. That's the dream. It actually loads zeros in all of those. This is brutal. Is there FMA float 4 instruction? Can this even be float 4? No, this can be float 4. None of this is float 4. Because none of these have stride 1. Where is the stride 1? Stride 1 is at the end. So IDX 6 is stride 1. It's not worth upcasting. I know float 4 is a data type in opencl. I'm aware of that. But I'm saying, like, what could we make float 4 and make better? The answer is kind of nothing. It's not like we can coalesce any of these loads in stores. I don't actually think it can be the... I understand. I have other stuff that generates float 4s. My point is, I don't actually think that's going to make anything better. Like, we're upcasting. Okay, so the optimizer is figuring out to upcast. Oh, I do want to include the intervention. Oh, hang on. Let me go here into kernel search. I want to bring back... import debug. I don't know how much simpler that k-opt is. What did I just change? typing any imported but not used. Yes, I know. Upcasting is great. Oh, we have new pull requests. We can see them right here in the convenient CI Discord channel. Oh, the symbolic test for correctness. Yeah, you want to take a look? Let's see. No, okay, so why did you remove this? In general, don't remove tests, just add tests. Yeah, don't remove this stuff. I would. Yeah, that's cool. Yeah, don't remove the string stuff, but you can add in the min and maxes. I will. Those are fine. Like, I agree that the string tests aren't great, but you didn't replace the string test by just checking the min and max. Sorry, I'm distracted again. What? Why is my target SM? Is this right? Fine. I just wish there was like a thing I could enable. It was like fast CUDA. And it just makes everything fast. Parallel thread execution, I say. Okay. I mean, we're getting like 30% of the max flops of the chip with this. So really, we just need to fix the bugs in the optimizer, allow it to run for 2 instead of just 1. Well, let's just do that now. Let me remove the cache. I call it cache kopt, we'll remove it. Now we're going to run the example, but we're going to edit this to allow 2 opts. I'm going to get rid of the debug for now. X. Is the new Triton backend? We haven't used the new Triton backend yet. I mean, that might be the answer too. We might just want to start using Triton. Let's see how this does. Where is this code, by the way? Oh, it's in kernel search. Oh, okay. So that's like, you see, this is actually a 2 thing speed up. First it got a 2x, and then it got an 18x by adding in the second upcast. Oh, that's sick. 18x, yeah, that's a good order of magnitude. Yeah. So that's getting like 5x. That's pretty good. These little kernels don't have anything to make them faster because they're already so little. Now, I think there's some bugs, unfortunately. So this might no longer have correct behavior, but I don't think they're like bugs that are really breaking, what's possible. Right? The great thing about multipliers is they multiply. So that's getting us a that times that. Now it's better to work on layer merging. I think the real thing to do now, but it might be nap time first, is to work on the correctness of the optimizer. Like, it requires 2 upcasts in order to make these things good. Like, let's hope this one finds another one that's fire next, right? Like, that one went from 344 milliseconds down to 221 milliseconds. And I think it's going to find, like, another intervention. Yeah, okay, good. Look, it found another 2x. I mean, it's not as great as I would have liked, but it's pretty good. We optimize and fix the optimizer first, then we optimize again. Yeah, it has to do with, like, these optimizations might all be okay. There's only some of them that are broken. By the way, I'm actually just going to put K opt here. Didn't break the test today. Is kernel search done in other libraries? Yeah, other libraries sort of do kernel search. tinygrad, in theory, should have a lot more flexibility with the kernel search than other libraries. And once we put like smarter heuristics in, this shouldn't be so slow anymore. Like we should know if an intervention is going to be brutally slow and just not search that one. I'd love to do this all with like models, but I don't think we're there yet. Okay, we're almost backwards through the kernel. We've almost gone backwards through it. So now you can see we're back at the reduce. So this is a reduce going from this to this size. So these are like the things that determine the weights. These are the backwards passes on batch norm. Okay. $500 milliseconds. 2 teraflops. That's a lot better. We're getting 2 whole teraflops, boys. 2. Don't worry that this is slower because I set debug equal to 2. 2 whole teraflops, that's right. We can try to find another one that's really slow and like see what's going on. We just need to figure out why the optimizer has bugs. That's the real thing to do. There's a chance that even when you fix it, it'll get faster. Okay, so they are getting 24 teraflops. We are getting 2 teraflops. Okay, we're only about 10x off. That's pretty good. The big wins are here. These kernels just don't need to exist, but they don't really use any time, so they don't really matter. The reduces, oh yeah, those can definitely be made faster if those weren't 16s. From 64x off to 12x off, right? 10x is much better. That's right, look at all the progress we're making. Okay, this one could be faster. Like, why is that only 4 gigaflops? That should be more gigaflops than that. So those are all the forward kernels. And then here we're at the loss. This is the end. Now we get to the backward kernels. Those are pretty good. Well, the backward kernel is pretty fast now. Oh no, those are the backwards weights. These are the backwards kernels for the images, and these are the backwards kernels for the weights. And I think they're actually fused. These are the backwards for the batch norms, but I think these are actually fused with yeah, okay. This one is brutally slow. Why isn't this getting faster? It's not a 4080 Ti. It's only a 3080 Ti. It's not that good. I need more subscribers if you want me to afford a 4080 Ti. Yeah, PyTorch has a hand-rolled optimization. Okay, all right, I found another one to make it slightly faster because I allowed more than 2 opts. Yeah, we just need to improve the optimizer, but we're getting there. If you can convince me why you need subs, I give 25. I'm not a whore, bro. You don't have to subscribe. You just make me sad. All right, we got 3 teraflops. That's better than 1.4 teraflops. All right. We did okay. I think that what we'll do is we'll end off this stream with I can't go eat another burrito because then I was just tired for the rest of the day. We got to go get other food. I think we'll end off this stream by playing in a place where we actually maybe can be competitive, and that's of course on the M1. So it's unfair to compare ourselves to this crazy optimized NVIDIA code because we aren't planning to beat NVIDIA. And I'll show you guys, just so you know that I'm not making things up. We can go over here to tinygrad.org, and you see that so the goal is to be 2x faster than PyTorch, but the goal of that is Q2 next year. And notice how it's still Q1. So think about it. If we went from 64x to 12x today, that means we're getting a 6x speed up every day. And that means by Wednesday, we'll be a lot faster than PyTorch. What do you guys think? Next year is now the current year, yes. So that's yeah, right? If we just get 6x every day, we just got to get our 6x tomorrow, all right? So we'll stream again tomorrow and get another 6x, right? That sounds good. But it's actually not as important to get NVIDIA to be fast. It's more important to get or GPU. I just updated the board. We want to be the fastest training on the M1. NVIDIA is a very far away target, but PyTorch MPS is so broken. Yeah, we're hyping our... Should we SPAC? Yo, guys, should we SPAC the Tiny Corp? Let me just show you something before you're like, tinygrad is stupid, okay? So this is test ops, right? Test ops compares torch operations to tinygrad operations, right? So we can also say torch equals 1, which will actually use torch. It's basically just comparing torch to torch. Now, we can say MPS equals 1, and this is going to use torch's MPS backend. Watch what happens. Not only are there bugs in torch's MPS backend, right? And this isn't any code that I wrote. This is entirely just torch. Not only are there bugs in torch's MPS backend, you'll see here that it just crashes. Which M1? This one. So remember that we don't have to compete with NVIDIA. We have to compete with PyTorch MPS, which crashes. Okay, this is without any optimizations. Let's see how we do. I think we can beat crashing, right? In fact, we already have beat crashing. Don't worry about that. You can just say GPU equals 1 and it works. Why does that take so long to download? Poor cs.toronto. No, university has a ton of bandwidth. All right, let's go. Come on. Now it's just being slow. I'm bored. Let's go. I regret killing that. Yeah, I have CFAR on this computer, but not this computer. You see, you can tell this is a different computer because the text is tinier. But now it's the same size and you can't tell anymore. Ha 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 ha. Can we get a progress bar for fetching? Yo, if someone wants to merge that, here's the code for fetch. I'll show you where it is. It's in extra utils. Here, this is fetch. So we're using requests.get. Is there just an enable for a progress bar? No, there's not. Python request get progress bar. All right, you can write this, but it has to be a small amount of code. That looks like a lot of code. Do we already depend on tqdm? I think we do. Okay, you can use tqdm. You can write, okay, fine. You can improve this to output a progress bar. I will merge that pull request. Fetch definitely needs a progress bar. A 2 million line microservice for a progress bar. That's right. Oh, I finished. Okay. So on the M1, we get 231 G-flops. Let's throw some kopt on there and see if we can beat that. We'll give it 2 kopts. And it's search. Is it being slow? Looks like it's being slow. It finds all the same basic interventions. If tinygrad can beat other libraries on the... I don't actually think hand-rolled complete network implementations will always be the fastest. Okay, I agree, yes, if you're doing the complete network, but a lot of that should be able to be fixed by putting in just the right shapes. So tinygrad is now beating everything on the 845, but I did have to write a whole bunch of hacks to do it. So you can see them here. I mean, they're not really hacks, but I had to make the shapes correct. So if you read this code here, these are my shapes for the 845, and I also had to make image textures work. But with both those, I got the fastest possible thing on the 845. Now, yeah, you would still beat it if you're implementing the whole network by hand, sure, but actually that's not even 100% true, right? Like modern optimizing compilers have gotten so good that they can beat, obviously they can't beat the best assembly programmer in the world, but they can beat most assembly programmers. So I do think it's possible to get to a point where a library can beat most, most people. We should maybe talk about how far along we are. And then this needs to, I should add one more. If someone wants to do a quick pull request, if someone wants to just get something merged into tinygrad, just literally add 1 to the float so that it won't justify like this. Literally just add 1 to both sides of that. Like it's like a 7.2, make it an 8.2. So how many G-flops does it get with kopt? Well, it's running kopt right now. Kopt is unfortunately insanely slow. But kopt can get smarter, and we can figure out how to do this better. I'm writing tinygrad on my own? No, I'm not writing tinygrad on my own. You can be a contributor to tinygrad. We have a lot of great tinygrad contributors, and you can be one. But tinygrad is also very tiny. It's not 1,000 lines anymore. 1,000 lines was just a tagline for hype. Tinygrad has gotten a little bit fat. Tinygrad is now 1,780 lines. But that now includes all the stuff for the 845. So Tinygrad's actually being used in opencl. It's like I said, it's the fastest inference on the A45. A lot of the training stuff still needs to be optimized. The higher layers are pretty good. The low layers aren't that good. We should probably, really, in order to be competitive on NVIDIA, and the only way we're really going to be able to get close, I think, is using the Triton backend there. The problem with the Triton backend is any improvements we make to the Triton backend are not going to translate to the M1 because Triton's not going to work in the M1. Whoa, look at that, 13x, bro, 13x, and that was a slow-ass kernel. The kernel was taking almost a second. It does, remember, it does cache all these, even if you're on the optimizer once. There'll probably be good ways like to just abstract some patterns quickly. You can see that the interventions it chooses are almost always the same. Oh, my mouse is slow. My mouse is slow right now. So yeah, there's no speculative execution really on GPUs, and we don't need speculative execution. The beauty of neural networks is they run the exact same data paths every time. But huh? I don't understand. I don't understand this one. That just seems broken. Yeah, stream's lagging because I'm running on this computer. Oh, these are the worst. These are the worst kernels. Are there any more of them? It'll also be faster when we reduce the number of kernels. Llvmlite, yeah, I know, it's slow. Let's go. I don't even want to know what it's doing now. How do we compare speed with PyTorch if PyTorch backend crashes? Well, it doesn't crash with CUDA. Yeah, the cards have some out of order exec. My point is, like, there's no branching in neural networks, so you don't need any speculative execution. Oh, come on, let's go. Oh, there's more of these stupid kernels. Oh, there's another one after this, because, okay, this is the... Yeah, there's no CUDA on M1. Yeah, but we're not going to beat CUDA. You can't beat CUDA. The amount of man years that have been poured into CUDA, we can beat on the M1. I want to make tinygrad actually a very usable. In Q1, our goal is to make tinygrad a usable library for training on the M1. You can compare the CPU backend. Here, you want to compare the CPU backend? Oh, I'll show you how to compare it. I have some tests to compare. All right, you want to compare the CPU backend? Let's go. GPU equals 1. This is on my other computer. Test speed versus torch. Pretty good, right? So the only ones where it's slower is here, and doing a 1-by-1 add. So that's our comparison to the CPU. Very fast. Now, of course, if we compare it to CUDA, I have some bad news. Oh no. That's actually using the CUDA backend instead of the GPU backend. If we compare it to Torch CUDA, we're in for a bad time. Yeah. Yeah, so, you know. Yeah, Torch CUDA is pretty good. Well, yeah, but again, the problem with Triton is we can't use Triton on the M1. Oh, here we go. We're on the M1 now. Oh, it got 2x faster after all that work. And it gets nans for the loss. Did it even get any faster? What was it before this? What was it with k opt equals 0? Okay, it got about twice as fast and way less consistent. What about torch metal? Yeah, that is torch metal. Torch metal crashes. Oh, you want to compare the speed? We can compare the speed. That works. So if we do test speed versus torch, this is comparing CPU to CPU. You want to compare it to, so this is comparing GPU to CPU. You'll notice that torch is actually insanely fast here because it's using the AMX. And we can compare it to the MPS. It's slower. Like, but some of it's a little bit unfair because just launching a single kernel is faster. So like these ones are actually the same speed. Like there's no way to write these kernels faster really. This is all just launch overhead. You finished adding tqdm, but you can't emit pull request due to being at work. Yeah, if someone wants to add that, I will merge that. We are all developing tinygrad together. We are all part of the Tiny Corporation. Yeah, so I mean that's just brutal. Yeah. All right, I think we go eat lunch. And then we, not on stream, fix the bugs in the optimizer. Oh, tinygrad will stay tiny. Hey, is this a stupid project? Today is discouraging. Why was last week wasn't discouraging? Why was Wednesday not discouraging? Can we raid someone? No, we can't raid someone today. I don't feel like raiding anybody. We have a lot of viewers. How are we doing on viewers? Unless Skybree's streaming. If Skybree's streaming, we can raid Skybree. 826 viewers. No, the real tinygrad better not be the friends we made along the way. It's probably faster than TensorFlow. No, I mean, it starts up faster than TensorFlow. I'll say that. By the way, look at some of these insane gigabyte per second numbers. Like these are getting close to the theoretical maximum of the GPU. $912.4 is the theoretical RAM bandwidth limit, and like we're getting close to that with some of these. Where's the fastest one? See, like look at like ReLU, look at we can look at the PTX outputs and compare. Yeah, we can. I mean, we might get there. Right? That might be, okay, all right, you want to really make it fast? I think we can do that. I have to make the optimizer. So that, I mean, that might be the idea. The idea might be to do what I did basically for SNPE on Qualcomm. And so on Qualcomm, I just went through each kernel manually, saw what their thing was doing, and wrote something better. So, I mean, we can do the same thing for Torch. We can get their kernels. I think their kernels hopefully can... We can figure out how to make their kernels use the same data format that my kernels use. And then it's just a question of making the code good. You compare tinygrad to some super optimized for that one implementation. Yes, I'm aware, but if we can beat that, we can beat everything. You know what I'm saying? Like, yeah, of course, it's not... So if kopt equals 2 actually works, I do think that that will be as fast as most... like normal implementations, because this implementation is about 10x faster than what you usually say. Maybe we need another 2x still. Maybe this one is 5x too slow. If they're getting 20 millisecond step times, you're probably more likely to see step times of like 100 without the optimized stuff. We don't need to optimize tinygrad. Just teach it to optimize itself. Yeah, I know, that's the goal. No, we don't need tensor cores. We do not need tensor cores. I turned tensor cores off. For this one here. Where is it? For this, I turned tensor cores off. If you put in that special TF32 override disable thing, yeah, if I run with that, there's no tensor cores. You can see it. What do you mean? There's nothing there. Oh, I guess over here he's talking, but this isn't tensor cores. $500 milliseconds to 50 milliseconds. We were actually just a straight up 10x off. Yeah. So this is taking 50 milliseconds a step, and this is taking 500. Assuming the optimizer is actually correct. Spending a lot of time in Python. Spending a lot of time in Python. Let's put the cache back on. See how it does with the jet. Oh, that got us some more speed too. Wow, it's super fast. Okay. So that's taking, let's do it exactly. .714 divided by 97, because it's doing 97 steps. So yeah, our step time is 48 milliseconds. Nine times off. welcome. Thank you. Yeah, if we turn the JIT on it, it's faster because we're not spending all the time in Python. Ooh, you wrote some stuff on the tinygrad wiki? Exciting. Yeah, down from 50. We're off by 9. Ooh, pretty nice. We have the tinygrad Discord now. Oh, adding tqdm should work. I'm always worried when it should work. Don't do this. No. No. You can't do that. Could someone explain? Can someone comment on that GitHub? I'm not logged in to explain why you can't do that. The layer bugs are not that big of a deal. The kernels are just slow. Don't do that. That's all n squared. I do like how short that is, though. That's nice. No, don't remove the string tests. No, string tests good. Someone please comment on this and complain. Yeah, it's n squared. That's right. That's right. Sometimes I just like running it and watching it run. Oh. Yo, we're only 9x off, guys. That's pretty good. Wait. Okay, this is just a bug. That's the wrong gflops. That's wrong gflops. Oh, because it's still counting the gflops here, I see. All right, that's double gflops. That's a bug. I don't know. Someone could fix that. It's stupid. We'll just hack it for now. Okay, now it says the right gflops. All right, 2.6 teraflops. Does Python have string builder? No. No, you do a join, yeah. You just replace this with, replace dat with an array. You want to append the chunks to an array, and then you want to do join. It's my address. You're buying my lunch. No, M2's not that good. It's the M1, basically. Oh, if someone wants to add whitening and can write like a really small implementation of whitening, I would merge that pull request. Because that's the only thing that we didn't do. Oh, we should put SE on. Because it really, we have to compare it fairly. How many new, oh my God, how many new kernels is this going to add? Nice try, Swatter. Okay, that's not too much slower. That's fine. So the only thing we didn't add is whitening. So good. This is actually a fair comparison. Oh yeah, it doesn't print them anymore because it's using the yeah, this is the only one that's right. It doesn't print them anymore since it uses the jet. I should make enabled JIT. I shouldn't just do that by default. I want to CLCACHE. Someone needs to clean up all the stupid environment variables and replace it with all these OS getEnvs should be replaced with a helper function. Like, this is a common pattern everywhere in this code. Can someone file an issue for that? Okay. No one, no, you're making me log into GitHub. So this is without CLCACHE. It actually prints the things. And then this is with CLCACHE. Are we not missing an optimization abstraction between the LLOps and the operators? No, that exists. That's all. The AST stuff is all that. Added pull request for fetch progress bar. Let's see this one. Ew. So much lines. Bar.update size. Oh, this is smart though. Can you just do that? Oh, see, like the combination of the two of you will make something good. If you don't have to track dat and you can just return and you can just say dat equals r.content down here, oh, that'd be the best. Yeah, you see what I'm saying? Between the two of you, there's something good. You just need to work together. Oh yeah, we need to. Okay, yeah, we need to file an issue about all those int os.getEnvs. Here's something. If you want to contribute to tinygrad, I really want you to think about writing the highest quality code you've ever written in your life. All right, like I just want the code to be so high quality, so no one will be like, "This is Twitter." Between the two of you, there could be something good. The AST handling is sort of repeated in each accelerator. Not really. So we have a class here in AST. Sorry, no, it's in ops, which gives you AST exec functions. But I agree with you that some stuff is repeated, and that's why we have this AST class out here. So this is an AST class that's outside, and there actually isn't much repeated anymore. I would take an intern at the Tiny Corp. We don't have any money though. So if you're actually serious about wanting to be a Tiny Corp intern, you can be a Tiny Corp intern, but it's not a paid internship because, like I said, we don't have any money. Though I might be able to get you an office and food if you're serious and you're very good. No, if someone's serious about wanting to be a Tiny Corp intern, I can probably get you housing too. I can get you housing and food, thanks to comma.ai. Comma can probably provide that in exchange for 20% time of the Tiny Corp has to be doing comma.ai improvements. I get your computer to work on. I can get everything but a salary. Because, like I said, the Tiny Corp doesn't make money, which is a problem. Office and food for someone very good for the Tiny Corp. The Tiny Corp also is looking into making money, and if we do make money, I can give you some percent of that money. We're looking into selling merch. Alex and I have been talking about selling overpriced t-shirts. Overpriced Tiny Corp t-shirts. But yeah, no, I will get you housing and food through Comma, and we'll have an office to go to. I'll get you a desk. I'll get you a computer. Do I actually rent that office space? I'm thinking about it. Should I rent the office? No, we can't rent the office because we don't make any money, guys. The Tiny Corp t-shirts. Oh yeah. Tiny shirts. You sure it shouldn't be a third person combining the two pull requests? We sell enough shirts we can rent the office. I think that sounds right. No, but yes, if you want to intern at the Tiny Corp, you can apply to I think it just says geohot at Gmail. It's geohot at Gmail. And we can we'll hook you up with some food and shelter. Guys, I'll give you 100% of the Tiny Corp's current revenue. No, Comma's not actually paying the Tiny Corp. We do that for free. Comma's like our client that we work for free, in exchange for, you know, being the Tiny Corp having real users. It's a partnership, okay? It's a partnership. $0 billion, I know. No, we have a lot of stuff to support, but mostly what we have to do in tinygrad is refactors. There's a lot of good refactors to do, and you've got to reduce lines. And you can't reduce lines with code golf. We have to reduce lines by doing proper refactors of things. Yeah, I work for free for experience. Like, it's not like this. There's just no money in Tiny Corp right now. But no, here's my pitch. Here's my pitch. If you want to actually be, if you want to be an intern, you want to be employee number one at Tiny Corp. Well, we're hiring. You can come work at Tiny Corp. If you want to be employee number one at Tiny Corp, basically, it doesn't have equity. It doesn't have anything. But what it does have is this. And here's my real plan for making millions of dollars at Tiny Corp. There's a lot of companies out there with failing AI accelerators, right? And the reason they're failing is because they don't have enough manpower to optimize the shit out of it like CUDA. But you'll be able to use tinygrad, and your experience with tinygrad will translate to making accelerators fast. Yeah, you can, I mean, yeah, no, if you want a more serious internship, I will give you, you can just join the Discord, and if you make a lot of good contributions, I will make you a tinygrad intern on the Discord, and you can pick your color. What color do you want to be? I remind you that there's a very high quality Discord, and if anyone posts dumb shit, you'll be banned instantly. Am I a millionaire or not? I don't know, guys. I don't know. Does it matter? The Tiny Corp has no money. You're asking me to fund the Tiny Corp? Yeah, that's not really how the Tiny Corp works. You want to be a remote employee for the Tiny Corp? Yeah, I think you're going to be a remote employee for the Tiny Corp. Again, there's no salary. And there's no equity. Wow, the Tiny Corp's a scam. Geohot trying to scam people, hiring for no salary and no equity. I'm going to go post about this on our anti-work. The rolls. The rolls was less expensive than you guys think. Does Tiny Corp support H-1B visa? No, that costs money. We don't have any money, guys. The LLVM stuff definitely needs a refactor. Yeah, the LLVM stuff is decent, but There's a lot of junk in the LVM stuff. Like this stuff is all junk. This needs to be replaced with symbolic. This engine stuff should be moved into runtime. So there should be a runtime for llvm.py. If you make the LVM stuff really good, I'll let it not be a symlink. All right. Oh yeah. No one's finished. This pull request could be cleaned up by someone and finished and made good. Replace sign with GT0. There's just like one little bug to fix. Already posted on our anti-work. Is this another cheapy scam? Guys, you don't understand. I literally lost thousands of dollars on cheapy. I'm the worst scammer. I'm the worst scammer. Should we make a token? Do we need to make a token? Is that how we can fund the Tiny Corp? No, but the Tiny Corp has no money. No, we're in San Diego. What skills must the intern have? How long? TinyGrad's just a scam for everybody. Like I'm scamming myself, guys. You think it'll be fast? Someday? A rug push. You got rugged. No, you don't understand. There used to not be a rug, and now there's a rug underneath you. That's right. It's a rug push. Okay, governance. Should we launch a governance token? No, wait. No. It's actually already answered down here in the FAQ. When are you launching your governance token? Will there be an airdrop? And the only answer we got was bruh. So no, I don't think that's going to happen. If you need clothes, I might be able to hook you up with clothes. Look, anything we have at the Tiny Corp, you can have. The Tiny Corp's the scrappiest company. You get to work on AI stuff, and yeah. Oh, this is some of the most beautiful tinygrad code. Oh, yo, if someone wants to just do like, if someone, again, you want a one-line pull request to Tiny Corp? Okay. So you see this for padding, where we do padding times 4 if instance padding is int. We probably want to say, I think you can fix this by using make pair. Oh, these things are literally just make pair. Oh, look at this garbage. Look at that. That's just that. Just replace that with make pair. Oh, that's our goal. What would it take to get Comma to switch to tinygrad for training? Oh, you don't see my head is too big. Oh, sorry. I'm a terrible streamer. No, but really, the Tiny Corp is funded with Twitch subscribers. How does tinygrad determine which parts of the network it will split into separate kernels? So that's in lazy.py. So it's all done kind of at runtime. It can do a bunch of things. Oh, processing up. This is so big. Oh, this is terrible. Oh, this is terrible. But this is how it's determined here. I'm going to sell it to photographers. No, the Tiny Corp needs to make money. And tinygrad needs to be good. Thank you for subscribing. No, it's too tiny to have any equity to sell. So we can't have any investors because it's too tiny to have any. We're looking for contracts and sponsorships. Yeah, I remember. That was the business model now. We need a contract. That's what we need. That's another reason to contact the Tiny Corp. If you want a net to be very fast, and the way contracts work with the Tiny Corp is if we fail, you pay us nothing. We're very easy to work with like that. We're not going to try to, you set us a goal, and as long as it's a fair goal and a fair price, if we don't achieve it, you pay us nothing. If you refactor this code, you can't push it. What do you mean? Just do a pull request. 1 Twitch sub a month. Tiny Corp can, that can almost afford my lunch. Where are we going for lunch today? Sushi place open for lunch? The sushi place. It's not even open on Mondays. Should we go to Home and Away? No, I don't want bar food. Where are we going for lunch? This place is just look, oh, good, good. I'm glad their reviews are going down. This is a much better Italian place. This place, the food's terrible. They just like look good on Instagram. I was upset. Should we go to Rock and Baja Lobster? Congress Cafe, I went there yesterday. I got an arepa. It was $17. Okay, like guys, I'm poor now. It's not even like a joke. Ooh, maybe we'll go here. I've never been here before. Best pizza in America, eh? Cannoli? It looks pretty good. They make pasta too. Oh, it looks fire, bro. I think that's what we're having. Let's go there. Do I eat out every meal? No, sometimes I cook. But I think we're gonna eat lunch, take a siesta, and then fix the optimizer to not bugs. Oh, we got a level 3 hype train going. All right, I appreciate the hype train, guys. Thank you for subscribing. This is the only money the Tiny Corp makes. I did watch the Lavender Haze music video. It was nice. I love Taylor Swift. Oh, now we have 3 pull requests for the progress bar? Ooh, big make pair changes. Oh, let's see. Yeah, but you got to change this one too. See, this is what I mean. Go all the way with it, right? Fix this one too. This one's going to require a little more thought. But that's basically make pair here. Maybe that's enough. Maybe I will merge that. A third version of the same progress bar code. No, you didn't even get the indentation right. 2 tabs. 2 tabs. Wait, and did you test this code? No, you didn't test this code because where does dat come from? You didn't test this code, bro. This one's probably fine. I probably will merge that. I don't know. That's actually not that easy. I'm like thinking how to do that. I will merge you if the tests pass. I'll have to go enable all the tests once I log back into GitHub. Yeah, I bet some people use ChatGPT. See, it's just garbage. Yeah, who's a contributor to tinygrad? Let me log into GitHub over here. Okay. Well, let me enable the tests for make pair changes. So yeah, we enabled the tests here. Wait, I wanted to file some issues. What issue did I want to file? Refactor os dot into helpers. Let's see what else. Yeah, so we're running the By the way, if you're not ready for me to merge a pull request, you should mark it as a draft pull request. Yeah, no, this one, no, we need the string test back. The string tests were covering stuff. This is not. Yeah, the other make pair line's a little tricky. I agree. Maybe we don't want it. This is still an improvement. And we'll see if the tests pass. tinygrad has a very comprehensive test suite. You're going to make a PR to remove all the tests. Well, that's not a very good PR. I can't believe I wrote that garbage everywhere. We'll call it like get option. Yeah, that'd be nice. Get option. There's our wiki coming. Look, we have a typo in the wiki. Someone can fix that. We also have lazy buffers, which are like lazy ops, but they're buffers. No, I'm not trying to use argparse. Like, I like the environment variables. Oh, and then it should also take an optional default. Get option should take an optional default. Looks like opt is 2. Right, so we can replace this with something like opt equals get option opt 2. All right, oh, that'd be so nice. And then we can remove this import OS everywhere. Oh, that'd be so nice. All right, someone can definitely do that in a pull request. Check other fetch pull requests. All right, let's see. All right, what do we get here? Ooh, dad equals r.content, stream equals true. Ooh, this one looks pretty good. Okay, why is this on a separate lane? Why? Okay, do you need this int here? Maybe you do, but either way, just put that there. That doesn't need to be on 2 lines. Think about it, right? Also, you know what else I realized? You don't actually need to write the file as chunks. We're loading the whole thing into memory anyway. What if you just wrote for chunk and tqdm pass? You see what I'm saying? All right, let's try it. Can we write a test for fetch? Do I need to fetch again? Where's that fetch to? Why? Where is that file? Where does fetch save things to? I don't even know. Here we can say no cache equals none. Right, now it fetches. All right, let's try a magic one-liner. Import tqdm. Stream equals true. And gonna use total size here. Did I leave my face big? Not that big. Module object is not callable. Oh. There we go. Except it's slow. Oh, the content for this response was already consumed. Okay, so none of this code actually even works, guys. Switch to a train nest. Don't print all that crap. It does fetch mnest, right? How does that not fetch mnest? Do I have mnest? Is mnest in the... I included mnest? I know what will fetch if I do opencl compile. There we go. Okay, notice how that kb per second is wrong. There's bugs in this. Chunk size 1024, so it's chunks. So the unit is actually KB. Guys, these are all wrong. This is ChatGPT shit. All right. So this is all chunk. So chunk size is 1024. What's unit scale? Oh, if one are true, oh, I see. Any other number will scale with. No, there's another way to do this. Unit divisor. Take back the housing and just only get food. So total isn't wrong. The problem is each one of these is actually incrementing by, so this might be rate, manual override by, I think rate is probably right. No, it's not right. All right, well, it turns out none of you guys had the right answer. You also wrote way too long a code. tqdm requests progress bar. All right, let's see if anyone here got it right. tqdm total size in bytes units IB. Okay, this is doing progress bar.update, which is terrible. I mean, we could do that, but that would upset me. See how much effort you got to put into one line? One or true. We'll scale total and n. N is number of finished iterations. Oh, all right, all right, all right. We got a good one here. No, this is wrong. Okay, I'll show you why this is wrong. Because if I do total and do 1024, look, it says it's 512K. So, okay, oh, you put unit KB. Oh, does that work? But then does this turn into M's? It's too fast. Maybe this is right. Hang on. Okay, maybe this is right. I mean, this PR still is not right. Sorry, I confused content with style because you know, this is the wrong tabbing. And what kind of imports is that? What's even? Why are these here? Like, what is that? But you might have had the right idea with units if we put unit equals KB. Okay, let's do the hibc one. No, look, that's kkb per second. That's wrong. This ChatGPT garbage. I'll be upset if we have to update the bar. It uses streaming API. Multiple people use the streaming API. That's not the problem. Dynamic end calls. I mean, okay. If you want to cheat, this should work. But of course, it's now insanely slow. I'm going to use all the we need something that increments by that much each time. Okay, I'm upset about this, but it's going to have to be a few lines. I think we are going to have to update it with the current buffer. There we go. Not a gzip file. Why is it not a GC file. There we go. Right? Now. I just let's take a second and let's compare. I hate your ChatGPT garbage. That's a different. Why are there all these changes here? Rebase. Everyone closed their pull requests. Everyone closed them. Like, I don't want should work. I want good quality code. If you want to intern at Tiny Corp, you gotta write shit that looks like that. Right. How clever is that, by the way? Is there a better way to write that? Is there another way to write that as one-liner? Can we just talk about how we spent one line? We spent one line, and it's upsetting that it had to be one line. It would be nicer if it didn't have to be one line. It should have been 0 lines, but fire. Wait, also, we don't even need that fetching anymore. That's kind of stupid. Yeah, that fetching, that can just go. We can get rid of that line because we have a better line now that makes a progress bar. You feel like that code should be added to the Stack Overflow post? Yeah, because, you know. I don't want that one. Bro. Goat shit. Oh, and then also, why is this chunk size so pathetically small? Should make it go faster. Poor Toronto, I'm really spamming their server. Look, it's faster. Go progress bar. Why couldn't someone write that? Why none of y'all write good code? How many FPS is the progress bar? Lazy happens all after the gradient stuff. Lazy is all after gradients. Gradients are all here in MLOps. This is gradients. This is some of the nicest code in tinygrad. Each thing and the derivative of the thing. But somehow JLU makes nan, so there might be bugs. Oh yes, please fix this. Please, can someone please finish that pull request and write good stuff? You can add it for other props, not just CLCACHE. Well, you didn't rebase, and yes, you have to do it for every prop. No. No. Why do you have an int here? No. You guys, do you want to be good programmers or not? Like, do you think I just want a replacement of... Why would I ever want this? Also, why is it here and not up here with the other ones? You guys, do you want to be good programmers or not? Do you want to write mediocre shit for the rest of your life? Ugh. No, you want good programmers, you need to pay good money. No, that's bullshit. I've seen people who get paid a shit ton of money and write terrible fucking code. It seems to not really correlate to how much money you pay people. No, really. I mean it. I mean it. Do you want to see you know how much Twitter was paying people and how much dog shit code there was at Twitter? Like, I just want everybody to take a minute. Please, everybody, take a minute and read the GOAT progress bar. That is the kind of pull requests that we want to see in tinygrad. Not let's add 10 lines of garbage that doesn't even work. Layer merging is in no, layer merging is in lazy. That's in lazy. At least it runs. Yeah, Twitter runs, yeah. No, stop. Please write good code. If you're gonna submit pull requests to tinygrad, please write good code. Like, it's not, you don't have to write a lot of code. You just have to think and, like, care, you know? Oh. Fucking, don't get me started on the Waymo safety page again. So you didn't want a non-function, non-readable. I even showed you guys how to write it. No, I'm not learning Scala anymore, but nothing against Scala. It's fine. I should spend the time on Rust instead of Scala. Does it have to be all Python witty built-ins? What witty built? Oh, that I used if there? Well, otherwise, it's a lot more lines, and like that's fine. There's nothing like particularly like. Are there hard things here? Yes, we still use mini key value. Yes, it's very good. All right. We got our first pull request that actually gets merged. This one. Kevin Gilpin, congratulations. Your pull request gets merged. The test passed. Yes, it is 2 lines. But can we notice how Kevin Gilpin managed to write the thing and only made one completely irrelevant, useless change? Which I should reject the PR for that alone. If the PR was just this to that and this to that, like that's nice because it made code simpler, right? Like it got rid of all these extra words. Now, I don't know about that, but otherwise it's good. Big make pair changes. Big make pair changes with no description. You guys, do you want to be good or do you want to not be good? You guys can ask questions. I can't even give you free channel subs. I don't even have that. The Tiny Corp doesn't have any money. Big impact. Really, you think it has to do with how much money you pay people? I've seen software engineers getting paid like $400,000, $500,000 who work at some FANG corporation, and then I see the code they write, and I'm like, oh my God. You know, you think your progress bars were bad. Their progress bars would have been 100 lines. I'm upset that this had to be 2 lines. It does though, I think. There's probably some really stupid, clever way to put it on 1, but then that's just too stupid. I really want there to just be like a with side effects thing, or be able to put semicolons in here. I mean, I guess I could have put the if in there too. Like I could have put like a, yeah, I just need that as a side effect. I think there's better ways to do that. Hang on. Like, all right, so here's another way to write that. That might actually be better. So I can also write it as like open bracket x comma bracket that. What do you think of that? Kind of like that better. Still constructs a list though. Is there something better? What is this? I don't even understand that. I mean, does this work? What if I don't make it a tuple? No, that doesn't work. That might be the simplest. You can't put the tqdm in the if because the if is called every time the loop runs. No, like, there's no semicolons in here, right? Let's look at the Python operators and see what we can find. No, look at my upgrade to the progress bar. Oh wait, why does that have a, no, that semicolon doesn't work. I mean, that is fast. It just constructs a stupid array. So probably do it like this, and that might be faster. Yeah, constructing a tuple is probably faster. Juan Coperu, thank you for gifting subs. I appreciate you. Don't need to write code anymore. No, it writes terrible code. All right, we're announcing a new policy on this channel. All future mentions of ChatGPT, using ChatGPT, fucking ChatGPT, getting a hand job from ChatGPT are banned. Add block term. How do I do that? Term. That's right. That's right. You know all the Luddites who are banning AI art? We're not banning AI art. We're banning talking about AI art. I would like to point out that my new implementation of a progress bar is 1, 2, 3, 4, 5, 6 characters shorter and more obviously correct. Oh, I gotta pull first. Oh, but it's gonna. Improve progress bar. Boom. I don't love this either. I wish there was just... Is there a function I could call that just returns the first element? Yeah, none of this stuff's good. Ooh, let's read all the built-in functions. One of these is probably good. Min and max are almost what we want. No. We wrote this is the best you can write it. Yeah, people do love this. We need lunch though. Oh, we need lunch. Should we just order pizza? You don't want to see me work on the optimizer. Like that sounds so painful. No, we could write on the optimizer. All right. If you guys are liking this, we have a lot of viewers. Let's order some food. Or let me just look around quickly and see if there's any food. Yogurt, that's it. lot of viewers. We'll keep going. Let's order food. I'm glad you're learning, bro. I'm glad you're learning. Dot index. No, it's not gonna work. George, I think you are psychotic. Thank you. All right. Should we order meatballs, guys? I know this is a triggering. How come that pizza looks so good? Okay, all this Chinese food's terrible. Never go to P.F. Chang's, by the way. No, we'll get some Thai. Thai sounds good. 5 minutes until closing. What? 55 Thai kitchen. Picked for me. Thai god over rice. Alright, what have I ordered before from this place? Order again. Drunken noodles. No, that sounds savage. Get some Thai style fried rice. And a Thai iced tea. Spicy basil chicken. That sounds pretty healthy. Oh, it comes with an egg. Oh, that looks fire, guys. Look at that. It's probably not going to be nearly as good. All right. Got spicy basil chicken and a Thai iced tea, which is mostly sugar. All right, let's go. Complete my order. Oh, some tom yum soup. Oh. You can use map operator item getter 0 data to get the first element. Yeah, but that's not what I want because I still have to construct the thing. I basically just I'm looking for a built-in function that's just this, right? Like, is there a function that's just that, right? So it's my Scala thinking. I'm not paying for priority. It's not going to get here faster, and I will tip, but only if you bring it to my door. You know how that works, Uber Eats. I agree with your new terms. All right. Spicy basil chicken will be here in 20 minutes. I am starving now. We got to find some food for now. What phone is this? It's OnePlus. It's an Apple OnePlus. Okay, let's find the bugs in the optimizer. We're gonna do it. If we don't do it now, then we're never gonna do it. And you know, and what there's like sayings for this. It's like drunk is better than never or something. What? I don't know, something like that. Late is better than, I don't know. If it takes one woman to make a baby in 9 months, how many babies can 5 women make in 3 months? And the answer is 5 because they were babies. You've had to wait 10 minutes to post this? For X in R either content or X. Yeah, so the problem with or X is that's not right. I agree, and I thought about that. The problem is if that other thing's not true, the or is interesting. The other one will return true. That's, I kind of like that. Okay, so use an or operator. I'll show you why it doesn't work. It's tempting. Wait, what does that return? Actually, that might work. What's 23 or 54? 23. Nah, that only works if that's always false. No, but you're assuming, what does progress bar update return? It returns true, but not always. Sometime it'll return nothing. Though this probably works. Yeah. Do you think that's more readable? It's a little bit longer. I actually think that's more readable. Can I try with just or? Yeah, it won't work. I'm gonna leave it the way it was, because I think there actually are things that can break this. Like, can I do... Oh, that returns false. Where there's nothing that can break the other kind. But that's just the same as B sub. You're right, though. Or is almost what I was looking for. What are the other Boolean operators in Python? The problem with or is sometimes it'll actually return the thing from progress bar update. You can do end, 0, or bool. No, I can't. Yeah, we got nerd sniped on this hard. Now, any and all return Booleans. This just isn't true. W3 school's up here lying. Right? This just isn't true. I can use or, I can do 23 or 20 or 24. But it's not just a Boolean operator. Here, mixing Boolean expressions and objects. Short circuit evaluation, sure. No, I think with the end false is the best you can do. Well, that's fire that you can chain like that. Okay, are we ready to debug the optimizer? Oh, we got TIST coming. Oh, that's gonna be good. Because we're out of highball. Oh, Chick-fil-A. Will the food arrive in 20 minutes? Well, I don't think it said 20 minutes. Wait, latest arrival by 4:05? No, I actually can't do this. I actually can't. I can't do this, guys. If my food doesn't get here till 4:05, I'm starving. Alright, I'm gonna go eat a cracker or two. I'll be back. We're taking a 2-minute break, 3-minute break, 4-minute break, and then we're gonna come and we're gonna fix the optimizer. Thank you for the OR suggestion. It was a good one. I didn't think about it. I got an apple. Actually, I'm gonna put it in kernel search. Ritter, thank you for gifting subs. Write a partial function that updates the progress bar as a side effect. I think we're done with the bar. I don't think we're gonna mess with the bar anymore. All right, wait, I do have some ideas. All right, we're gonna go out the bar for another minute. Oh. Okay, so you have way too many parentheses here, first of all. Second of all, this function is really long. You don't actually have to do this. You can just make a you can write a one-line function there, basically. If you want to write the good version of that, you can write like yeah. I'm fine with what it is. It constructs the array. It's not slow. It's not making copies of X. It's fine. It creates a new pointer. It's fast. I promise it's actually faster than a function call. Yeah, or true end X works as well. But or end fall. Actually, I do kind of think that's the nicest thing to write. Oh, it's slow. Is that always true, regardless of what object this is? No, I don't like R1. Is this always true? No, I know when it returns true, but I'm not, like, is this true for any arbitrary thing I put here? Or are there things I can put here that will break it? I mean, look, if we're going to start writing things like that, we can even go back to this. Was that the best thing all along? Hey, the object needs a len or bool method. No. 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 Stop it. That one's fine. Ah, there's a delicious apple. here's part of the problem. Part of the problem is that these things don't have random stuff, so we'll have to fix that. We'll fix that. Lazy op has no buffers. What? It does have an attribute buff. That's wrong. All lazy ops do. Oh, source, never mind. I don't get it. It should be right, actually. Where do I use that? I use it here. K.code. Oh, test AST doesn't take in an AST. It takes in K. That's a scam. But these aren't actually correct is the problem. We don't know if they're correct. We don't know if they're correct because it's full of zeros. So we want to... we want to fill them with random stuff. We have helpers in here to get all the buffers. Maybe it's lazy. No, that's realize buffers. How do I get the buffers? It's really an ops. Yeah, get buffers. There we go. From tinygrad.ops import get buffers. Get buffers AST before testing need to fill the buffers with randomness. Okay. And then actually, so we can say for B and buffs, but we want to find the root of each buffer. So these buffers have host buffs. So while b.hostbuff, b equals b.hostbuff. Right, that should get us the actual host buffers. GPU object has no attribute host buff. Is it underscore host buff? Self.buff. It doesn't actually matter. So for b and buffs, we say b buff dot copy in, and we want to fill it with trash. So we can say b dot base shape np dot rand n b dot base shape. Let's just read the tensor code for that. I should just be able to see read update shape there, I think. Does that work? All right, we found a bug. Nice. That was easy. More food. Estimated arrival 3:50. Oh. All right. I actually don't like to reprint the shape tracker there. That's a lot. I know I contributed to this, but go here. Dot shape self.sts sub I dot view sub -1 dot strides. That's good. And we can actually, we don't need debug 4, debug 3 is fine. Okay, here's the first one that broke. Thank you for saying I'm good looking. I appreciate you. I'd appreciate you more. You know, Instagram needs a way to filter your DMs by women. No, it's all well and good until we try to upcast. I don't really understand this. What? Why didn't it reduce? Why did it become an ew? Somehow it became an ew? Right. We can't upcast 3, 4. That's not divisible. not all. ST shape up axis or ST shape. That's not visible. It's not divisible. I don't get it. By the way, if I get rid of that, does it work better? Well, that made it further. I don't exactly understand why, but okay. No, I broke in the same place. Okay, it's not that. Oh, no. Okay, this should actually be okay. Because it's... Oh, wait a second. That's all in the testing, the AST. Okay, we need to fix something. During the test AST, we have to set debug equal to 0. I don't know if this works, but I hope it does. Sometimes you just get spam. Can I access local variable debug? Global variable debug? I think that works. No, because I think it like when it imports it. That sucks. Oh, unless do I need global here? Last try at that. No, it's still spamming all this crap. Okay, this doesn't work. Yeah, so this is okay. This is the let me fix the prints. That'll just make it easier to read. Kernel search. It's in between testing and applying. Here. This is what fails. Okay, so it's doing an upcast on 3, which should be legal. Wait a second. How come there's 3 here now and there's only 2 here? Oh, because it's not how old works. I need to fix this. Oh, no, but old isn't right either. That's actually after the upcast, I think. Yeah, that's not right. Actually, I have an idea. I'm just going to get rid of debug. Okay. So this is what breaks here somehow. What breaks? Does float 4 not work? Or maybe the bug's in float 4. Well, let's disable float 4. Huh. Okay, the bug's in float 4. That's cool. Oh, then the bug's probably just in the store. Oh, that's probably simple. I probably just did the store wrong. V-type float 4. No, it seems right. V.type equals float 4. Well, V.type's definitely float 4. We're dividing by 4. see if that's the one bad one. We're just testing. Okay, that's the bad one. It's also possible, remember, that the bug could be in reading the AST. No, probably not, because that size would already be done. That works fine. It's the same basic idea. Oh, does the reduce function not work? No, this is opencl. That doesn't make sense. Do you order it wrong? So this is one kernel. And we should have an identical kernel. No, I see the problem. This needed to be float 4 also. Yeah. Oh, this is some deep bullshit. Let's just allow float 4 false. Uh-oh. But I kind of worry. I kind of worry that that's why it was fast. Let's fix it? I mean, we'll fix it eventually. But we have a hack now. And our hack is wonderful. Let's get rid of that. Cool, it works. None type has no attribute copy in. Yes, I know about that. Sweet. Great. It does all sorts of upcasts and it's good. Try them on the gem. Tests pass without float 4. Is that my food? No, Jennifer has my order in Mission Beach. Good thing we found that apple, man. Rip float 4. No, it's still, I mean, some of the stuff still uses float 4, but. All right, let's see how much our speed was actually fake. We should still be able to use the cache because I think the cache is still good. Okay, a little bit of our speed was fake. In exchange for correctness. What's wrong with test asked? Oh, this problem again. It doesn't work because our batch size is really big. It doesn't fit on CPU. It's not fake. Just, yeah, it's a little bit slower. Actually, that's probably just the actual speed difference in not using float 4. Let's run this with test AST. See if we get any more bugs. All right. We'll let that run and I'll show unknown error. What? Minus 999? It's not a real thing. In search 1, shouldn't that be in a... This one's broken? I don't get it. I can show you guys where the weird thing is with float 4. And then we can see if there's any more bugs. Well, one way we can tell simply if there's bugs is we can run it with and without kopt and see if we get the same answer. Lowering the batch size will just make everything faster. We'll be able to just test. I mean, you'll be able to find the bugs. What? There's no... Guys, the best code is no code, okay? Then every time you have to write a line,
you're making a mistake, right? So there's only one good way to write code, and that's not to write code. Now, unfortunately, sometimes what you need to do takes more than 0 lines, and then you might have to write some. No. You see the problem with your 0-line solution. It doesn't work, right? Writing small code is great, but if it doesn't work, it's actually useless. No, the best process is no process. Absolutely. You guys read Elon's things? You know what they are. All right, we're going to figure out what that bug is in a minute. I'm going to let this run, and then we're going to figure out what our speed actually is. No, I don't think it's actually much slower. I think we were just... All right, I want to point something out here. Look at how 200 milliseconds is being spent in Python and 0 milliseconds is being spent in CL. That means that the CPU code is running slower than the GPU code, and you need a JIT. So we can run it with CLCACHE equals 1. Look at our speed now. Oh, we're getting a respectable 2 teraflops. That's pretty good. Now, I don't like the way that loss isn't going down, and I feel like if I go like that, the loss is going to go down. No, that looks equally stupid. Is the learning rate too high? I was going to need to recompile if we use a different learning rate. Oh, that's crazy. No, that doesn't fix anything. I don't understand why it doesn't go down. Okay, regardless, we should be able to fix test AST now. CL wait for events. This is some scam. Oh, did we stupidly allocate all the memory? That's possible. Oh, this might just be because we wasted all the memory. This might be an out of memory error. Oh, we got a mismatch. That's not a mismatch, they're so close. Are we wasting all the memory? I feel like that's what we're doing. Invalid command queue? Get rid of the k-opt. Can I test AST on there? No, I can't even test AST. This doesn't even have to do with the optimizer. Yeah, look at all that RAM. Oh no, that's not RAM. Never mind. I lied. Invalid command queue. Okay. We can think about that. We can have a conversation about that. Well, that's good. Let's figure out what's wrong with my AST test. Using a CPU buffer. Device is a CPU. The only thing we're doing is from CPU. I mean, this test is wrong anyway. I'm not really happy about this test. Because really it should use the shape tracker and respect it, but it doesn't. Though invalid command queue is aggressive. That means we compiled something bad? Is there a bug in 2CPU? np-empty self.shape self.contiguous. Just Okay, well, that's a better bug. How does this ever work? This is crazy big. $28 megs, that's fine. There's a bug here, I don't get it. What? Oh, that's just wrong. Okay. Cool. No, still with the same crap.
Relative resources. Yeah, so it's probably running into a problem trying to construct this. Yeah, it's this. It's failing. Yeah, okay. It's trying to allocate something that's 9 gigabytes. That fails. All right, well, let's lower the batch size more. If we put it down to 8, it should probably be okay. It creates virtual tensors in order to do the convolutions, but this thing is actually oh, I got a phone call. Oh, please, please. Oh, I think okay, that might be my fault. I think the code changed. I'll be back. See, in San Diego, it's not like the meatballs. Your food shows up. No, it's my fault there's no door delivery. I'll still leave a tip. I didn't update the code. The code changed and I didn't update it. So but my food is a little soggy. Everything's a little soggy. It's rainy. Yeah.
$30 meal, I know. Yeah. Binary out shape mismatch? I don't even know how we got that. I don't know how we got that. You know what it probably is? It's probably still wrong. Put that back there. That's what that was, right? Yeah, there is fine. Actually, it'll be faster if I use 2. No, but I might try to optimize on that. What do you think of 5 as a batch size? Are we excited about 5? Nobody's going to try to optimize a 5. Oh, fast. That's a really small amount. Surprised it worked all the way up until there. I love that I wrote this AST test. It's very powerful. Like for each AST, it compares the execution of that AST to the execution on the CPU. It's not as good as it should be though. Only copy the base buffer and retain the shape tracker. Requires CPU shape tracker implementation. But there's good ways to write that. Okay. Let's run it with kop2 and then see if we can find any more bugs. Well, first let's run it with kop1 because we didn't actually test kop2. We also test kop2. Basil's chili pretty good. Look, it is picking 5s. Okay, any bug in the ASTs? By the way, these things being made fast are actually copy outs. Oh no! That one doesn't even look like it has an AST. It has an intervention. It's just wrong. Let's try it. Again, this is terrible that I'm writing it like this. All right, we found one. Doesn't look like it should be wrong. It was probably because it was also combined with this. Wait, this definitely has group for reduce. Oh, it doesn't. Oh, I see. See, this is what it looks like grouped for reduce. No, no, it's not RTOL. No. No, there's real books here. Oh, I think I know what it is. Yeah. Okay. That's wrong. It's what's the right answer here? Oh. Yeah. Okay. This is a real bug. Do you see it? Oh, I like this. Oh, I like that we found something. Okay. So the output size, yes, we need 2 outputs in the reducer. Yes, thank you. Yeah. ACC1 is just being thrown away here. Well, that's good. That forced us to think about a bunch of things. All right. I think we'll fix that bug, and I think that's the stream. This is a pretty in-depth bug. Give A-Rater 2 VIPs soon. Yeah, I can see that. In order to really get VIP, you got to point out something I missed. I think that was the general rule. Nah, that's good enough. Congratulations. Welcome to the VIPs of the channel. You were probably right. I should probably focus on making my map mall fast. If you want super VIP, actually implement two things in the reducer, 2 outputs in the reducer. Bam. Our views have declined. Not live? Okay. We can write this pretty fast, I think. So the problem is that we have multiple accumulators. And if we have multiple accumulators here, for ACC in accumulators, for I, ACC in enumerate accumulators, ACC decal type, ACC talk,
Oh wow, I did this badly. There should be self buff tokens 1 top I, self buff tokens 1. This is going to fail to compile. Oh, well, that's a stupid reason for it to fail to compile. Yeah, here we have mid. New accumulators for ACC in new accumulators token output sub I for I in range accumulators. I hope this stuff's right. Enumerate. Output cannot be interpreted as, range and length. Okay, it's wrong for some reason. Why is it wrong? This looks like an even stupider one to be wrong. Okay, because this should not be. Yeah, sorry. How did act 0 get there? That's not right. Yeah, okay, sorry. Need that. There we go. Fixed. Now, I'm not sure that's right. There might be times when this breaks. I have this stupid path with upcast for mid reduce. How do I ask this question without being offensive? It probably just is an offensive question. You probably shouldn't ask it. Oh, see, that's some stupid looking code right there. Wow, that's real stupid looking code. Whatever, though, what can we do? Okay, let's test AST. Test AST will find the bugs. If there are any more, I think we probably got them. That's it. We're done. All right. I'm a little worried that one's going to break the test. Actually, we'll just test it. That one's kind of complex, so yeah, yellow, we'll commit it. Fix multiple accumulators. That might have broken the test. Oh, good. I wasn't triggered too much today. That was a good solid day's work. Oh, now learning should work, you're right. I mean, it has tiny batch size. Oh no, that's Tubby. No, no, not Tubby. Don't do it on Tubby. We haven't even gotten to kopt equals 2. We'll have to try kopt equals 2. Does someone want to write an AST fuzzer? Yo, that'd be fire. Right, we could just fuzz. We can fuzz for symbolic too. Yo, it's so fast. Gigaflops. I should probably make batch size an option. Still waiting for my get parameter. Must have deleted the cache. All right, does it learn with batch size 512? Oh, it's so brutally slow. That's 3 seconds. Yo, in that amount of time, the other PyTorch implementation has already finished. Oh, why am I large and covering the code? Oh, sorry, we're almost done. We're almost done with today's stream. Look at the loss go down. Down, 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 down. Now let's see if the loss still goes down when I turn on the kopt. That's all I want from today's stream. If we can turn on the optimizer and watch the loss still go down, we'll see how much progress we actually made. We fixed some big optimizer bugs today. You know, is it possible that the float 4, no, the float 4 is a different bug. I don't understand the float 4 bug. The float 4 bug can be many different things. We're really not getting the benefit of 2 kopts. We should test with kopt 2. This was a productive stream? Yeah. Didn't Google release a Python fuzzing engine? Yeah, but fuzzing for what? You want to do sets of transformations that are guaranteed to be the same. Skybreeze plenty for fixing the flow 4 bug. No, we can try. I don't know. Fixing these bugs is kind of boring.
I imagine the most fun thing, I mean, I think where we got the most viewers was when we were writing this. Like, that is beautiful code. Then it all kind of became trash and fell apart. But imagine that was just fast. Okay. Whoa, look at the loss go down with kopt. With kopt? Loss goes down. With no kopt. Loss goes down, but slower. Wow, the kopt kernels make the loss go down even more. That's just randomness, don't fall for it. Double speed, it's pretty good. And we haven't even turned on kopt 2. Kopt 2 gets us 10x the speed, but we don't know if kopt 2 is correct. Kopt refers to how much we've opted the case. Oh no, but I know this is gonna find a bug and then I'm gonna be upset. I know this is gonna find a bug and then I'm gonna be upset. Yeah, I saw Jeff Bezos following the EACC founder. You gotta wonder about these tech guys. I mean, I don't wonder about Elon, but you know the other ones. Yeah, Alex texted me that last night. Whoa, look at that, look at that, look right there, guys. Look right there, look what we just caught in the wild. We just caught a reduction, a 10x reduction followed by a 3x reduction. Look at that reduction. Look at that. Fixing this bug might have even made it faster. Unfortunately, we can't test. We need to cache the kopt level in the thingy. It's too short to be copyrighted. All right, what questions we got for today? Long stream. Things are looking good for kopt 2. It works. kopt 2 works. Okay, this is kopt 0. kopt 0. Now we're going to go to kopt 2. If you thought that kopt 1 was a lot of kopt, you are not ready for kopt 2. Double the kopt. No stream tomorrow. How much speed up do I think kopt 2 will bring? Well, I think we might hit the Python limit. I think we might, so if it's running at 850, if we more than 4x it, we're hitting Python, we'll have to get the cache to work. It doesn't actually train in the cache, and we can figure out why that is, and that's a whole other thing. Because we're not actually updating the things. We can fix that though. My cache doesn't work right now for training because it's like the weights, you see what's going on, right? It's not actually updating them because everything's SSA. But we can fix that. Like the JIT will have to trace what things actually get updated and then blah, 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 blah. Look at this. Look at this one. We got a 3x speed up, and then with kopt2, we got another 13x speed up for a total speed up of 39x. How many lines over 1,000 are we right now? Oh, it's bad. It's bad. Whoa, that's really bad. What even are all those lines? What lines did I add today? It's bad. Any progress? Yeah, we found kopt2. And kopt2 is not wrong. It might be wrong. We can't test it with the big kopt. Medium grad, I know. No, it's gotten so big. Weren't we at 1.7K? I don't know what we did today. We wrote a lot of lines. All right, well, you know, join the tinygrad Discord where everything is on topic. Nothing off topic. The source of the memory leak is kernel caching. Interesting. You can join line count and you can discuss line count. It was 1169. Now somehow we've gained another 40 lines. And it was not from my progress bar, which was very small and efficient. Whoa! And the loss goes down. Wow. Wow. We haven't hit the Python limit yet. We're almost kind of at the Python limit. It seems like the more we optimize, the more the loss goes down. I can't believe I'm going to sit here with no kopt while this thing runs slowly. No, it's the same. And the loss isn't going to go down because it's broken, but whoa. For reference, with kopt 0, even when we turn on the cache, kopt 3 is even better. That's true. Should we do kopt 3? No. We can't go. That's too much kopt for one day. We got a 6.5x speed up, guys. Too bad we can't stream tomorrow, because if we stream tomorrow and get another 6.5x speed up, then we're almost as fast as PyTorch. And then if the day after that we get another 6.5x speed up, we're like 5 times faster than PyTorch. How does it stack up against PyTorch now? Well, that's how many gigaflops we get. Which actually, fixing these bugs did make the gigaflops go up. Oh, unless it's better with this batch size, but that doesn't make any sense. Bigger batch sizes should have more gigaflops. You guys can, at home, you can download this and you can try kopt equals 4. There's no limit to the amount of kopt you can use. No safety here, guys. No safety. It's gonna go so fast. Please link tinygrad Discord. Oh no, we don't want the noobs joining the tinygrad Discord. If we link the tinygrad Discord in chat, noobs will show up. And if one noob shows up in tinygrad Discord, we're gonna ban them. If 10 noobs show up, we're gonna shut the Discord down. Because we can't have nice things. We can't have nice things if noobs show up, you know? Wow. Look at all that speed up. You can try. Just try more kopt, guys. Try kopt at home. Do you have to implement models yourself? No, the backpropagation is built into tinygrad. This includes the backward pass. Like, you understand that 120 milliseconds is actually a very reasonable step time. Most people would be very happy with a step time like that. It just turns out that we have to get our step time down to 50 milliseconds and also make the batch size 4 times larger. So about 10x. We're about 10x off from optimized PyTorch. Then imagine we beat PyTorch, guys. Just imagine we beat PyTorch. That would be a great victory. Someday. We'll fix. No, if you want float 4, you gotta write float 4. You can debug float 4. I gave you all the tools you need in this stream to debug things. You can debug and fix float 4. We'll beat PyTorch and we have higher adoption than them. Well, unfortunately, the benchmarking stuff on the M1 is annoying. NVIDIA has much better benchmarking tools. The M1 is like interleaving stuff and cheating. I have to see if there's an option to turn that off. Why is PyTorch faster? I don't know, man. You couldn't make it faster. You saw what we did. Look, we went from this speed to this speed. So we just got to keep doing that. You thought what only did automatic differentiation? tinygrad does automatic differentiation. Of course it does automatic differentiation. Did you see me write? We wrote a model today. Did you see me write any derivatives? I did not. No, but like, wait till we write super kopt. Wait till we write neural network based kopt. Wait till we turn kopt into a game. pytorchisbad.com. Does anyone own it? Don't use pytorch.com. Wow, does anyone own these things? All right, guys. Thank you all for watching today's stream. We mostly stayed on topic. We got some stuff done. Hinton thinks we should get rid of differentiation. Well, that's really easy to do. You can just delete the mlops. You can just delete the mlops thing. Thank you all for watching. If you're interested, the Tiny Corp is offering unpaid internships. We're also looking for contracts and sponsorships and other ways to make money because we are poor right now. So yeah, we're going to start selling some merch. How much is the most you'd pay for a t-shirt?